All right. Well, welcome everybody. Welcome to the 2025 WRI Partner Conference. It's good to see everybody. It's nice to come here when it's a nice day in Richfield. So thanks for coming and joining us this year. This is something we like to do every couple of years. And really there's two reasons for this conference. I think you guys have heard me talk about this before. The first reason we like to get everybody together is WRI has a few different research projects that we fund every year. So we like to get those guys to come and report on some of the information that they've gathered for us. And then it's always a good time to kind of get some other folks here to talk about some of the pertinent information that we believe you as restoration practitioners could benefit from. So we've got a pretty good packed agenda. There's lots of time for questions, and most of those folks are here in person, and so we've got lots of time to ask questions here back and forth, and then if you've got something we don't have time for, find them in a break, and I'm sure they're more than willing to discuss further their project. The second reason we like to get together is really this is kind of our opportunity for us to cross over those regional boundaries. We feel like as a WRI administration, one of the biggest things that's our responsibility is to facilitate these type of gatherings. These are the field tours, the regional meetings. It really is something that we try to focus on so that you guys are here to get to know each other, to expand your professional networks, to find folks that are doing things similar to you, to learn from those folks, and to help make these projects that we do together better. So we build this conference with longer breaks, a longer lunch period. Y'all got name tags so people know who you are. Take that time during the breaks and during the lunch hour to mingle about and get to know your fellow professionals. Most of the time when we have regional meetings, we like to go through and do introductions. I think the room's a little too big for that, so maybe we'll just kind of go through and see who we've got here from different agencies. So let's have you raise your hands or whoop and holler, whatever you feel like. State government, how many people here from trust lands? Let's start with trust lands. There's only like 2 or 3 of you, right? 1? I don't hear anything though. How about DWR, Division of Wildlife? All right, welcome. Forestry, Fire, State Lands. UGS. All right, Hugh and his guys over there, welcome. PLIPCO, anybody from PLIPCO? Anyone else from DNR? Anyone else from state government? Brad, you're kind of not though. How about the feds? Forest Service? Yeah. All right, BLM. Awesome. Anyone from the military installations? Awesome. Welcome, Russ, and your guys are here too. NRCS. Perfect. Awesome. Okay, Brad. Universities. Brad. Jody, thank you. NGOs like TU, MDF, Sageland I saw was here. Anyone else? Holler it out. SUA's here. Thank you. Nature Conservancy, TU. Anyone from TU? I thought I saw someone register from TU. There you go. Welcome. How about county and local government? Welcome. Any other private companies? Any other that I missed? Who are you from?
Master Association.
Okay. Awesome. Welcome to the Watershed Conference. Fish and Wildlife Service, Clint. Welcome. Okay. All right. Okay, just a couple more things. So we are streaming on YouTube live. It's a little bit delayed, so we're not going to take question and answers through the YouTube. But because we're doing that, when the question and answer time comes for each of the presentations, we're going to have mics. And we've got Daniel and Allison and maybe me running those around. We might be a little slow, so just wait till we get to you with the mic before you ask your question. We'll run as fast as we can. Okay, any other questions before we get going? Okay, we've got a welcome from Joel Ferry, who's the Executive Director of the Department of Natural Resources. Joel is the one who actually signs off on project funding. He could not be here in person, but he did record a welcome for us, so we'll play that. Go ahead.
Good morning, everybody. Welcome to the 2025 Watershed Restoration Initiative Statewide Conference. And welcome to beautiful Richfield, Utah. I wish I could be down there with you this morning. There's no place better in late May than to be in Richfield. And I want to give everyone a warm welcome to all of those who are joining on the live stream YouTube channel. My name is Joel Ferry. I'm the Executive Director of the Utah Department of Natural Resources, and I'm honored to help kick off today's gathering. This year marks 18 years of boots on the ground impact through Utah's Watershed Restoration Initiative. Now, since its start back in 2006, WRI has been a model of collaborative conservation, improving high priority watersheds through partnerships at every level, local, state, and federal. And at its core, WRI is a locally driven effort. This truly is conservation through partnerships. Projects are planned, reviewed, and ranked by the communities who know their landscapes best. Together, we've completed nearly 2.8 million acres of restoration across the state, and the impacts are immeasurable. Now, our shared mission has been recognized over the past 18 years through a focus on strengthening three key ecosystem values. Number one, watershed health and biological diversity. Number two, water quality and water yield. And number three, sustainable use of our natural resources. From restoring critical wildlife habitats to increasing water yields and building wildfire resilience, WRI continues to make a lasting difference across Utah, and it continues to be a model for the country. Now, today's conference, this incredible conference that you all are attending, is an opportunity to reflect on what we've accomplished over the last 18 years and what we have to look ahead and what we can do better together. I want to extend a sincere thanks to all of our partners, our project managers, our researchers, the private landowners, and other volunteers who make all of this work possible. Our strength, WRI's strength, has always come from the people, from you. And I want to thank each and every one of you for being part of this incredible 18-year journey, for continuing to support the vital work of watershed restoration in Utah. I have had the opportunity of going down and seeing, hands on the ground, boots on the ground, seeing the work that has been done all throughout Utah, seeing the successes, seeing how it makes a difference. Absolutely incredible when you see the benefit to our landscapes and the large scale impact this has, not just on public lands, but on private lands, and bridging the gap so that boundaries truly, they don't matter. What we're doing is truly beneficial for the resource. Let's use today to celebrate our successes, to tackle our challenges, to build new partnerships, and leave inspired to keep this work going strong for future generations to benefit. Thank you all for attending the conference today, and look forward to years to come of great work together. And one more thing. I just want to congratulate Tyler and your team at the Watershed Restoration Initiative for the work that you've done. This year, you were recognized as the Conservation Partner Award from the Bureau of Land Management. Now, this is a national award that is given out to a conservation partner who goes above and beyond. And truly, the Watershed Restoration Initiative does just this. This is incredible. Thank you, Tyler, for your continued work in Watershed Restoration Initiative, and to all of our partners across the board. We couldn't do it without you. So this truly is a wonderful award and recognition for the state of Utah.
All right, thanks, Joel. So that award was kind of a surprise, but you know, I said this in our social media post when we got that. It really is an award for all you guys. It really is recognition of this partnership and the effort of everybody. So thanks to everybody for this partnership and how well it's really something that we've gotten some national recognition for. So, all right, okay, let's go ahead and get started. Kent, this is Kent's PhD research, isn't it? Talking to us about annual nutritional condition dynamics in mule deer.
Okay, thanks all. Yeah, so this is going to be, today I'm just going to talk about part of my dissertation work. It's also a huge effort, a statewide effort that we do here across Utah. And it's, first I'll just like to acknowledge my partners at BYU, Randy Larson, Brock McMillan, as well as Dave Stoner with Utah State, and then Covey Jones, who's our wildlife section chief. So to start off, the focus of this talk is going to be on nutritional condition and the importance of nutritional condition in mule deer. So what nutritional condition is it's basically the integration of how an animal looks, its body fat, with its environment. And it has impacts on basically every aspect of an animal's life. So it impacts its probability of survival, whether it gets pregnant, whether it has fawns, and if it has fawns, does it have twins? It also affects whether those fawns, how fast they grow, whether they live, and whether they can be recruited into the population. And so the way things work in a simplistic model is that deer spend their spring and summer recovering from winter and putting on fat to try and get as much fat as they can entering that December. And then over the winter, they burn this fat to maintain their bodily function. And if they cross some threshold, typically around 3-4%, they run out of energy to maintain their body and they die. So from a management standpoint, we have two options. We can start them off on a higher plane so we can improve summer habitat and get them up to a higher level so that they decrease fat over winter, but they never cross that threshold. The other option is that we can keep them at the same level and we can slow that rate of decline over winter. And so basically that's a function of their winter habitat. And that winter habitat is where we focus most of our WRI efforts. Since this WRI conference, most of you already know this, but we've tons of projects. Many of them have focused on benefiting habitats for mule deer. So nearly 2,900 projects completed, 2.7 million acres, $418 million. And the question that we always get asked from the wildlife side of things is like, what have all these projects done to benefit mule deer? Can we put a quantitative value on what we've gained through this? Do we have habitat for another 100,000 deer, or what is that number, and how can we measure that? So what we wanted to try and do is combine all these habitat treatment data with our statewide collaring effort that we do, and we've started in 2014, so we've been doing it for about 11 years now. This effort has placed GPS collars on over 7,000 mule deer across the state, and we have collars on every management unit across Utah. And through, these are GPS collars, they take a point every 2 hours, so we've collected over 38 million points with this. So a ton of data looking at how deer are using the landscape. And so the simple thing we can do to start off is just like, well, what is the use of these treatments? And so this is just a histogram showing how many points are being used and how many are within habitat treatments. And so you can see quite a few in the zero. Mostly that's because treatments aren't available to these animals. So if we just zoom in on those who have a treatment within their home range, we do see quite a bit of use, some of them up to 75% of the locations within a treatment. If we look at summer, we can see even more 0 points. Again, most of our work has been on that winter range, so not surprising that a lot of summer range is untreated. But if we focus on those animals that are using or have access to a treatment, we again see a lot of use of these treatments. Some of those animals spending all of their time within a treatment. And so that's important, and it's great to see that we're getting use of these treatments. However, that doesn't tell you what the value of these treatments are for deer. So to get at that, we wanted to take things a step further. And so when we started our collaring effort, what we also started doing is every time we collared a deer or caught a deer, we brought it in for processing and collected a whole suite of data on it. Biggest things being weight, we took blood samples, age, and two main factors that make this really important. We took an ultrasound machine, and so there were some equations developed by a researcher out of Oregon called Rachel Cook, and we were able to take an ultrasound, measure her rump fat of these deer, and then figure out total body fat of these animals. Excuse me. And so by doing this, we could see how fat they were entering winter. The other part of this is we didn't just handle these animals once. We would put a collar on them. We could see exactly where they were using on the landscape. And then we would recatch these animals and see how their fat and condition changed over time. So just some examples of what we were looking at when we measured them. The middle picture and the top picture are the rump fat measurements that we get. 10 mils is a really fat deer when we bring it in the winter. 2 mils is on the skinnier side. And then this third graph here, or picture, is of their loin muscle, which we also measure and can look at how that changes over time. And so we collected these data in December to see how fat they entered winter. We also collected them in March to see how they changed through that winter. And then we would collect them again the following December to see how they responded to those summer habitats and how they're using that. So that brings us to this, what the whole point of this study was, is we wanted to look at all these condition data and understand how or what factors were driving the differences that we saw in condition both in winter and in summer. And so to do that, we looked at data from 2014 through 2021 and had a total of 1,300 individual deer with almost 2,500 capture events. Now, this is a lot smaller than the total 7,000. We shut it off a few years because this is part of my dissertation work, but also because these animals needed to be recaptured. And we don't always, for all those deer that we're catching, we're not always doing the recapture process. Some of them are done as part of our migration initiative and just kind of a one and done thing. So for December fat, we had 672 deer that were caught and then previously recaptured, so we could measure their fat and see where they were using. And for March, because they had to be caught in that preceding December and in March, we had a reduced sample size, but still 413 animals. So our response variables that we looked at were December fat, March fat, and then that overwinter decline of those fat reserves. We also looked at the predictor variables, which were some animal-specific things like whether lactation status, did it have a fawn or not, how heavy was it, what's its weight, and its age, latitude, which was mainly just a nuisance variable that where animals up in Cache Valley are a lot fatter than Pine Valley due to just having to have those extra reserves due to harsh winters. Climate variables, including precipitation, through winter precip, spring precip, monsoon, and fall, as well as temperatures for all those months. And then for the winter time periods, we looked at snow, totals as well as snow depths. And then we also looked at the use of habitat treatments, but in addition to that, we looked at, we created resource selection function to look at how much they were selecting for these, and we ran analyses on the beta coefficients for that selection. And then lastly, we looked at carryover effects, so how much did December fat impact March, and then vice versa? How did coming out of winter impact them that following fall? And this was all done with linear mixed effects models, using capture unit as a random effect, and then we did model averaging. So just getting into the results, what determines the December condition? First, that latitude variable is very important, just understanding cache deer are a lot fatter, as I said. And then also lactation was a huge thing. Whether they had a fawn or not was important, but then in addition to that, it wasn't just whether you had a fawn, it was how long they produced milk. So that's why this score is on the x-axis. Half means they had a fawn, but they stopped producing milk in like September. Some animals we noticed actually were still producing milk through December when we still caught them, and that had a larger effect on their fat reserves the longer they produced that milk. The other big variables were precipitation variables. Huge effect of monsoon precipitation. When we get good monsoons, we tend to see a lot fatter deer in December. Same with spring precipitation. In particular, April was the biggest driver. When we get good April precipitation, that has a large benefit for mule deer. We also saw a negative effect of October temperature. So as these hot, warm fall, when we get those situations, that tends to have a negative effect on the amount of fat deer have entering winter. And then we had, surprise. This was a little bit of a surprise, but the way they come out of winter actually had a carryover effect. So if you exit winter in good shape, you tend to enter December in a lot better shape. So when we have these hard winters and deer barely survive, that has a negative effect coming up that following December as well. And then lastly, we saw an impact of the habitat treatment. So the more time that animals spent within these WRI treatments, and this is summer time, even though most are not summer range treatments, the greater they spend in there, it impacted deer with adding potentially up to 1-2% of body fat on them each year, which doesn't sound like a ton, but that is quite a bit in the terms of the deer fat world. So looking at March condition and what drives that. So the biggest factor impacting March condition was December fat. So the fatter they are in December, the fatter they are in March. So just like March affects December, December affects March. So we have this cyclical effect of fat and condition of deer. We also, unlike December, we found an impact of age. So although age didn't affect how you looked in December, it did affect how you were in March, with older deer tending to be a lot skinnier exiting winter than your younger prime age deer. Also an effect, basically this is just a measure of winter severity. February precip, so the amount of snow, as we got more snow in February, decreased condition, and as colder, harsher Februaries had a negative effect as well. So no surprise, harsh winters, lower fat in March. Then the rate of fat decline, one thing here that's a bit interesting, so we also saw a huge effect of December fat on the percent decline. So the fatter you are in December, the greater your rate of decline over winter, which is kind of a product of just how the body works. If you have fat, subcutaneous fat in particular, you will burn it. So even though, it looks like a negative essentially, but the reality is, even with the December fat rate of increasing or being higher, we still saw December fat impacting that March fat, and that March fat was higher, which is the real key there. We also saw that age variable come out again, higher rates of decline for older animals. And again, these February variables, winter severity, deeper snows cause greater fat loss, colder Februarys cause greater fat loss. And then the final on this for WRI standpoint, we did see this impact of habitat treatment use, and particularly this was looking at the selection of these treatments. So animals who selected treatments more had a reduced decline rate of their fat reserves versus those who were avoiding it. And that was potentially up to 10-15% based on the amount of use and the amount of selection of those treatments. So if we come back to the initial example of just how mule deer work and what can we do from a management standpoint to impact this, what we found is that we can actually do both. Through summer range treatments, we can impact how much fat these animals have starting December, and we can also impact that rate of decline through these overwinter treatments. Now, it is important to note that precip has a bigger effect. All of our WRI stuff is important, but precip is probably your main driver. And so in really bad conditions, our impact is going to be lessened, and we're still going to see some bad things happen. However, it is good to know that we do have the potential to change the landscape and benefit wildlife populations in a quantitative, measurable way. And I guess the one thing two things I want to come just end with is I hope it's clear how tied together all of these factors are. If we look at this pre-winter condition, that December fat influences your survival, it influences your post-winter condition, and then that post-winter condition has huge effects, and I didn't go over it today, but through some other research we've done, that post-winter condition and how they exit winter has huge effects not only on that December condition, but it affects whether they have those fawns, how heavy those fawns are, how much they grow. It affects the doe's ability to lactate, and then the lactation comes and it impacts that December condition. So everything's tied together. So when we turn one knob through our treatments, we can have impacts across the whole deer's life cycle. And so it's really cool to see that the work we've been doing has had benefit impacts for mule deer. And so these winter treatments that we've been focusing on are beneficial. But I do want to also kind of put a plug in. I think a lot of the stuff we're seeing is that this summer range is at least as important, maybe more important than winter range for mule deer. So what we can do to improve summer range, get them into winter in the best condition possible, entering that'll help them exit winter in the best condition and hopefully improve our populations throughout the state. So with that, just want to acknowledge a ton of partners across DWR, BYU, USU, and other agencies, and thank you for your time. Take any questions.
Okay, any questions for Kent? Wait for the mic, Jim. Set a good example.
I have a comment for you, Kent, because I know you haven't slept, ate, been home for like 5 years now, so thank you. This is amazing stuff, and I think it's really critical that we get this shared with our federal partners especially in relation to how it relates to summer range treatments. So thanks.
Thank you.
Any other questions?
This is an easy one. How much of this is published outside of your dissertation?
I'm slow is what it turns out. So right now, hopefully by the end of this summer, we'll start publishing these chapters. Right now, it is not published, but it's on the list, but turns out with a full-time job, school, and a family, it turns to be hard. But we're trying.
Anyone else? Okay, thanks, Kent. I appreciate this. Okay, next up is Makeda to talk to us about Wildlife Tracker.
Okay. I don't know which one's the forward button, but the big green one? Okay, perfect. So for those of you who don't know me, I'm Makeda Hanson. I'm the Wildlife Migration Initiative Coordinator for the Division of Wildlife Resources. Today I'm just going to talk to you about how you can use Wildlife Tracker to enhance your restoration planning. The bigger green one. Okay. Before we get started today, I just wanted to talk a little bit about the things you should consider before you start looking at Wildlife Tracker. First of all, just because if there's not wildlife location data in an area that you're looking at, that doesn't necessarily mean there's a lack of wildlife use. We had pretty good coverage with deer use across the state, but there's still gaps. So just keep that in mind, that just because you're not seeing location information from Wildlife Tracker doesn't mean that there's not animals already using that. Additionally, Wildlife Tracker does show locations used by individual animals, and those represent various percentages of the overall population based on capture methodology and our purposes for capturing across the state. Like Kent mentioned, some of our projects are specifically for wildlife migration, some of them are survival, some of them are for neonate studies. So there's various reasons why we're doing captures across the state, which will influence at times what those look like. Just a reminder, even with heat maps, these are not resource selection functions. These are just a snapshot of where animals were on the landscape. Additionally, just because there's animals on the landscape where you're wanting to do a project doesn't necessarily indicate that you need to do a restoration project there. We do need to make sure that we're balancing food, thermal, and hiding cover. So just because you're seeing a lot of use doesn't necessarily mean that you need to do a restoration project there. And vice versa, just because you're not seeing wildlife use in an area doesn't mean that you couldn't do some restoration on the ground to make it more useful for wildlife. So just a few things to keep in mind before we get started. I'm kind of curious from everyone. I kind of see Wildlife Tracker being used in two ways. One is to actually go on Wildlife Tracker and look at how wildlife are using the landscape to plan projects. And another is where you have a project in mind, and you're using Wildlife Tracker to get your points to justify why this will benefit mule deer. So who's actually used Wildlife Tracker to plan a project? Raise your hands. A handful of you. Okay, who've used it more to justify kind of your existing projects? Okay. Who has never used Wildlife Tracker before? Okay, we've got a few. Okay, so I just wanted to go through a scenario with how you can use Wildlife Tracker to plan a restoration project. In this situation, I am not super familiar with the northeastern region, so I chose that project area using the WRI user role to plan a project in an area that I'm not super familiar with. So I'm just pretending in this scenario that I am a new fuels technician out of the Ashley National Forest. So on Wildlife Tracker, there's a lot of layers that are available. They can be a little bit difficult to find if you don't know where you're looking. So in Wildlife Tracker, you can see that circle with the question mark. That will link you to different various resources to help you understand how to use Wildlife Tracker. On the bottom of that is the Wildlife Tracker user guide. And in the appendix of that, on page 17, is a list of all of the layers available in Wildlife Tracker and where you can find those. And so with this project, some of the ones that I found most useful were land ownership, wildlife management units, which is what that WM uses, wildlife biologist districts. Just a caution, sometimes you'll have to zoom in and out because there's different layer extents on those. All habitat for mule deer. The WRI projects are in there, so the completed projects, the current projects, all the different project layers that you can see on WRI are also in Wildlife Tracker. Historic fire perimeters are on there, the land fire vegetation layers on there, and then also our range trend studies. So those were just a few of the layers that I found valuable in project planning. So there's a lot of words on here, but as I was looking on Wildlife Tracker, I learned what the Wildlife Management Unit was. I learned it was a high-use mule deer corridor. And if you click on the different layers, the metadata will pop up. And so I learned that corridor is mapped in 2018 to 2021. So I know with the WRI user role, when you first log into Wildlife Tracker, it's just a blank page, and you have to actually run a query in order to see what hot spots are on there for the wildlife that you're querying. And so if you can't find anything because we haven't collared a deer in that unit in the last year or something, you can always look at that migration layer, and it'll tell you at least what years that we had data to inform that analysis. I learned about past projects, learned about wildfires, and then learned about a range trend study, so I could go back and look at the range trend study in that area. And then also I learned that district biologist was Levi Watkins. So if you ever need to talk to the district biologist because you're not as familiar with wildlife management, their contact information is there as well. And hopefully you guys also have really great connections with your regional habitat restoration biologists who can help you with this information too. This is just an example of what that looks like, just the metadata that pops up when you click on the layers. So this is what the query function looks like in Wildlife Tracker. If you're not familiar with it, you can query by a shapefile that you upload if you have a project boundary in mind already. You can query by mule deer, wildlife management units. You can query by a variety of things, query by dates. In this instance, I queried for the year of 2024 in the North Slope West Corners, 3 Corners West Agate unit. And that showed me this hotspot map. So this represents 25 mule deer in the North Slope from January 1st through December 31st. So that didn't really maybe show me what I was hoping for, so I was going to look at 2 more years of data. So this is showing 37 mule deer from 2022 to 2024. And so I also wanted to see how these heat maps looked in relation to our wildlife migration corridors. So this is an interesting wildlife migration corridor. It's the longest migration we really have documented in the state, which is kind of cool. But this represents, the heat map represents 51 mule deer in the North Slope from 2018 to 2021, which is when we mapped that migration corridor. And then the completed projects are those green polygons, past fires are those pink polygons, and then the range trend sites are those, they look kind of black on the screen, but they're those maroon dots, just to kind of give you a feel for what we're looking at. So then I kind of looked at where we had location points along that migration corridor. It looks like there's a few places where either deer aren't really spending a lot of time as they're moving, and so I was wondering if maybe there were some habitat treatments that we could do to keep deer using the habitat in those areas. So this is the land fire data on Wildlife Tracker. The blue represents lodgepole pine forest, and the light green is an aspen forest. This is south of Ute Mountain near Brown Lake. So my northeastern people, I don't know how familiar you are with that. I'm not, but brownie. See? Uh-oh. Thanks, Tori. So I just looked at, this was a aspen habitat according to Landfire. So when I looked at that, I looked at the movement data, and I thought maybe there's opportunities here. Just a reminder, this should always be a first step. This should never be your last step. You should always look at these things on the ground, and you should always contact your partners to see how they can help you with this kind of project work. So that's just one example of how you can plan in Wildlife Tracker. I'm sure a lot of you use these more than I have and are familiar with these, but these are just a few other helpful tools. Obviously, the Watershed Restoration Initiative website will tell you a lot about past project information and what methods were used, show success photos, look at monitoring. Web Soil Survey is another one that's super helpful to look at ecological site descriptions, vegetation productivity, the rangeland analysis platform, the DDR range trend studies. If you haven't looked at those, they're super fascinating and have lots of history, like 40 years of history of photos, which is great. And then Maeve's going to talk about this later, but the new wildlife habitat assessment tool that has all of the wildlife resources, public data available. So those are other things that I think are helpful to include along with Wildlife Tracker in your project planning. Lastly, so after you've planned a project, what should you include in your WRI proposal? So you want to include maps of Wildlife Tracker. Within your maps, it's important to include your project polygons. Include landmarks or features so people know where you are, and those are easily identifiable in landscape. I would recommend a minimum of 2 maps, one that's showing your project area, and then one showing that in relation to the overall landscape and how wildlife are using the overall landscape in relation to your project area. Unfortunately, we don't have a way currently to differentiate by color heat maps by species. So if you're looking at elk and mule deer or other species, you're going to want to build 2 different maps because the heat maps will show up the same if you do two species. And I think it's better to represent those because elk and mule deer specifically will use things just a little bit differently or a little bit different time of year. So I'd build 2 different maps. Most importantly, identify what species are displayed on your map, how many animals are represented, and then the date range that you queried in order to get that information so that people can understand it a little bit better. Here's a few examples. The top one is just after you upload that PDF or that JPEG of your map, you can type directly into the comments on WRI what that means. So the top one just says existing elk data on the Morgan South Ridge Chalk Creek. It represents 133 animals with varying date ranges from February 2018 to April 2024. The blue is mapped habitat, the purple are cooperative wildlife management units, and then there was no data on the CAMUS unit that's in there as well. And then map 2, this came from the northern region, but it just talks about the project as well and talking about the heat map and what it represents by animals and the dates. I think it's important that this person put on there, it's important to note that heat maps and migration corridors are based on recorded locations and not modeled habitat. I know I mentioned that at the very beginning of this talk, but just a reminder. So yeah, there may be animals using those areas too. Lastly, provide context on how your project area was determined based on the use in Wildlife Tracker. So you can provide this in your in the actual text of your WRI proposal, and point out key features about the timing, the habitat types, and the species that show why that project is significant for wildlife. Here's a few examples. I don't necessarily want to read all of these. If anyone wants these as examples, I can send this to you. But basically, just saying why is your project important for wildlife? Why did you decide based on location data to do your project there? Whether it's you weren't seeing a lot of deer locations in that area, and it could be improved for fawning habitat if you increased herbaceous forage, or you're seeing pinyon juniper encroaching into sagebrush, and so you're going to identify that you're going to remove that encroaching pinyon juniper, but also retain the adjacent pinyon juniper for thermal and hiding cover. Just put something in your documentation about why this project's going to benefit wildlife. If you need help with that, if you're not a wildlife biologist, DWR staff is more than happy to assist with this. Additionally, if you would like to have DWR staff use Wildlife Tracker in ways that are easier, just because they can access things that are a little bit easier to look at rather than just heat maps, please work with your biologists in your regions. Monitoring, I just wanted to mention that you can do some pretty interesting monitoring with Wildlife Tracker, more of qualitative, but just on your own. This is an example from Torrey Mathis out of the northeastern region. This just shows bison use prior to the habitat treatment, which is that orange polygon, and then how bison really started to use the lower half of that polygon 1 year post-treatment. You could show this with heat maps as well, but this is what the wildlife biologists within the state have access to, is those individual location points, and they can also run animations to see how long they're in those areas and how they're moving around in that. So please use them where you can. Another example, I don't know if this will play. Oh, it didn't, that's okay. But this is a deer that was in Annabella, Utah. It migrated 45 miles and it spent its entire summer in less than a square mile, and it primarily used a habitat treatment project. This is one of Jim Lamb's projects out of the southern region on the Parker Mountain, and just seeing that this deer basically used that its entire summer just demonstrates the importance of these habitat restoration projects for deer. And that's all I had. One thing I was going to mention, when you log into Wildlife Tracker, I know sometimes for our federal partners you have firewalls that are causing issues. So once again, please reach out to DWR to assist as needed. Secondly, you'll notice there's a new sign-in that just went into place in about the last month. There's 3 different boxes you can check. Either you don't have any conflicts of use, you have potential conflicts of use with Wildlife Tracker, or you have, the last one is that you've basically disclosed any conflicts. So it is against the law. It's just passed in December. It's on all of our wildlife rule now that you cannot use wildlife location data to help with hunting or any type of personal gain. I just wanted to make you all aware that we do monitor wildlife use, or monitor use on Wildlife Tracker very closely. So if you have a hunting permit, I strongly advise not doing any queries that would look like they were going to be done to benefit you for hunting. If you do need to do something that happens to be in one of your units that you're hunting, there is that justification box, and I would just recommend that you write in there why you are using that for a work purpose. This is a really helpful tool for partners and for Division of Wildlife staff, and so we just want to make sure that it's a tool that we continue to use in the future. So we just try to monitor that and make sure that use is appropriate.
Okay, questions for Makeda?
Fascinating stuff. Thank you. Can you share access information so that we might take advantage of the tool?
Yeah, so I can leave you with a card, or anyone who needs a card, and you can just email me and we can get you various access to that, depending on your need.
Are there conservation species data on here, or do we need to keep those under the...
Yeah, so we have, in Wildlife Tracker, we have over 30 species with GPS information. Depending on the species, we allow people to see that or not. So like we do have Pinyon Jay data in there, but that's only accessible to the researchers who are working on that project. But there are some other species that we have in there, but we don't have a ton of data for conservation species in there at this point in time. But the Wildlife Tracker has the functionality to add those as people have projects. So another plug, if you have other wildlife movement data that would be beneficial to put in Wildlife Tracker, we can upload that into Wildlife Tracker as well.
Go ahead.
Makeda, that project on the Parker Mountain with that deer, that was a spike project, if anybody's curious, and that deer returned to that spike project 10 days ago for her second summer.
Sweet. Yeah, share your stories of cool stuff too. We want to share that out to people.
Any other questions for Makeda? So I'm just going to add to what Makeda mentioned. So when we got audited last by the legislature, they mentioned a few different internal programs that they wanted us to tie into, and one of them was the Migration Initiative. So like Makeda said, this is something that we want all of you guys to use if it's appropriate. Makeda's available, DWR staff are available. We really want you guys to start using this, so let us help you use it. Okay, thanks, Makeda. Okay, next up, Scott Gibson, who has been reassigned to basically the Pinyon Jay czar now, is going to give us an update on what's going on with Pinyon Jays.
Thanks, Tyler. Yeah, I was asked, I think it was 2018, Russ Norvell, our bird conservation coordinator, pulled me aside. He's like, hey, you want to be Pinyon Jay species lead for the state? I was like, yeah, it's fine. It's not going to be any work. And here I am 7 years later. I'm now the state Pinyon Jay biologist. So I was asked by Tyler a couple years ago. I came in 2022, and I did a presentation on Pinyon Jays and kind of the state of where we are. There's actually been a lot that's changed, and we've added a lot to our knowledge base in the last couple of years. So I want to just kind of give an overview of where we're at in the state with Pinyon Jays, and specifically I wanted to talk about the Pinyon Jay Conservation Agreement and Strategy. I know some folks in this room are probably familiar with this conservation agreement and strategies and how they work, but I'll try and keep it as interesting as I can and throw in some Pinyon Jay biology and information as we go along. We do have, it looks like we have a little bit of time. We're a little ahead of schedule, so hopefully there'll be some other questions that are maybe not necessarily related to the conservation agreement and strategy, but we'll see where we're at. So part of the reason we're really interested in Pinyon Jays, and we have been, there's a lot of different reasons, but one, if you look at this range map of Pinyon Jays, you'll see Utah is squarely in the middle of the Pinyon Jay range. We're actually the only state where basically the entire state is encompassed by the range of the Pinyon Jay. And the significance of this, obviously, is that any major conservation or management actions that take place for Pinyon Jays are going to have to occur here in Utah. And as I'm going to demonstrate here and show you, we've actually sort of been at the forefront of a lot of the work with Pinyon Jays. And so if you speak to other states, if you speak to a lot of the folks in other areas that are starting to work with Pinyon Jays, Utah has sort of been at the forefront of that for the last few years. I'm pretty fortunate to have been there. It's actually a super cool bird. We didn't know a lot about them, and we're just starting to learn that. And I think I've probably fielded questions from a lot of folks in this room, and you're probably frustrated with my response because I say we just don't know. And we're still kind of there, but we're getting there. So I'll talk a little bit about that too. Just a real basic background on Pinyon Jay biology. I think the name implies, right? They're going to be mutualistically associated. They're obligates with pinyon pines. So they do have that mutualistic relationship in these areas. They tend to have lower densities, though, once you leave those areas. So they are still found in places where we don't have pinyon pine. There's places in Utah where it's exclusively juniper, and we do still have pinyon pines there. But if you go to the periphery of the range, so California, they even occur out in Nebraska, Montana, Wyoming, in a lot of those areas where we don't have a lot of pinyon pine, you do still tend to find Pinyon Jays, but they're typically more associated with these large seeded pines like ponderosa, limber, Jeffrey pine. I get a lot of questions in Utah where we find them. They are almost exclusively associated with pinyon juniper woodlands here in Utah. Relatively open, low density pinyon juniper woodlands, oftentimes on the margins in that ecotone area between shrublands, grasslands, and pinyon juniper woodlands. I'm happy to talk a lot more about that, but I want to get to the conservation agreement and strategy here in a minute. But that is where we find them in Utah. Typically, there's about an elevational cutoff. I always say if I start seeing Doug fir, I'm not going to see Pinyon Jays. And that's generally true. We do occasionally see them in Ponderosa, but not very often. And they're highly social. And this is actually one of the reasons that Pinyon Jays have been studied for a little while. We didn't really know a lot about their ecology, but we knew a lot about their social structure. They do occur in flocks. I've probably gotten texts and phone calls from a lot of people in this room telling me that they've seen Pinyon Jays. Sometimes they actually legitimately want me to know, and sometimes they're just trying to annoy me. I do appreciate it most of the time. They do, but they occur in these big flocks, and it depends on the time of the year. In winter, multiple flocks will come together sometimes and form what I call a super flock, and that's when people tend to see these birds a lot. They're big, they're blue, they're noisy, so you get a lot of visual and auditory observations of Pinyon Jays, especially in the winter. But they do nest in these colonies, and the colony nesting is starting to wrap up here in Utah right about now. So they're early breeders. They tend to start breeding in February, and they go until about the end of May. But they've been observed to breed every month of the year, just to be jerks, because that's what they do. But typically, it's that February to May time is when Pinyon Jays typically nest, and that's when observations are kind of most importance to us, because that means they're going to be on their established home range, and within that home range, they're going to have a colony. So why are we interested in Pinyon Jays? Why have we been doing all this research? So BBS, which is Breeding Bird Surveys, which is a nationwide effort. It's oftentimes done by community science, as well as actual professional biologists have participated in this breeding bird survey. It's a road-based survey. It dates back to the mid-'60s, and if we look at the trend data from the 60s to about the middle of the 2010s, what we find is there's been a population loss of approximately 84%. So this is pretty significant, and it's actually one of the most significant declines of land birds here in the United States. There's some debate as to how well the breeding bird survey tracks Pinyon Jay populations, but the trend data is pretty definitive in that even if there are some flaws in the BBS methodology, we are definitely seeing some actual noted declines. The global population estimate for Pinyon Jays, I think this is a little low, but they estimate it to be 770,000. And again, this is based on that nationwide BBS trend data. But of note, the half-life, so when they predict these birds to be reduced by 50%, will occur at that rate in the next 19 years. Hopefully that doesn't happen, and that's what I'm here to talk about. So. They are an SGCN, which is the species of greatest conservation need in 7 states, and that does include Utah. So it was recently added a couple years ago to our Wildlife Action Plan. I see Paul Thompson on the schedule a little bit later. He'll probably talk a lot more about the Wildlife Action Plan than me, but it is one of our SGCNs, which does mean when you are doing a WRI project, you can claim Pinyon Jays, and if you've done that before, you've probably gotten a nasty message from me asking you not to do that necessarily unless it is specifically a project to benefit Pinyon Jays. Reason for that, they're getting a lot of attention right now from a lot of different eyes. And we don't want to be claiming Pinyon Jays unnecessarily on projects that may benefit them, but we don't have the data to back that up yet. I'm happy to talk a little bit more about that as well. Just a little background on their status. They were petitioned. This has actually happened right before I came and gave a talk in May of 2022. They were petitioned for the Endangered Species Act listing by Defenders of Wildlife, and that occurred in April of 2022. At the time, I said I expected the 90-day finding to be positive, and it was. If you're not familiar with the 90-day finding, essentially what that says is, does the petition have merit? And in this case, it did. Most petitions, as long as they follow the rule set that the Fish and Wildlife Service outlines, are found to have a positive 90-day finding. So this was not a surprise to us at all. It then moved on to a 12-month review period. And a 12-month review period is oftentimes considerably longer than 12 months. They actually expect that 12-month finding to occur in 2028. So you can see it's about 5 years instead of 12 months is what they're anticipating. And that 12-month finding is where they make that final determination. So that's where it will be either warranted, so it will be listed, not warranted, or warranted but precluded. If you're not familiar with that one, essentially it says that yes, it's warranted, but essentially we don't have the time and money to deal with this right now. And then in the interim, we are entering a period that's really important for Pinyon Jays, and that is the Fish and Wildlife Service will conduct what's called an SSA, or a Species Status Assessment. That's set to take place at the end of the summer and will carry over until just a few months before they make their final decision. And that Species Status Assessment, if you're not familiar with that, Basically, it's an overall assessment of the status of the species. It says what is the current base of knowledge that we have, what is the best available science, what is the current status, and what are kind of projected future outcomes for Pinyon Jays under different scenarios. So we're entering that stage. And what we're hoping to do now here in Utah is inform that process. So we have lots of different research going on and different monitoring efforts. There's currently 3 PhD students. I think a lot of you are probably familiar with them. There is one in the Great Basin, that's Emily Card out of University of Georgia. There's one on the Colorado Plateau, that's Hannah Wright. And then Rory Eggleston, she is based out of USU, and she is doing her work up in the northwestern part of the state as well. They're all looking at basically spatial ecology and how they move around in a managed landscape. So hopefully we start getting some of those data available for publication and use in the near future. There's also several new projects in the works. There's a USU project that may happen in the tri-state area up in the northwest corner, specifically looking at treatments. We did a lot of road-based surveys. I talked a little bit about that last time I was here. From 2019 to 2022, essentially the intent was to find colonies. At the time we started that, we knew of like 3 or 4. And then we, in that time, we managed to bump it up to probably over 100 known colonies. So that was a really successful effort. We're really proud of that one. And then last year, we started using a new protocol. It's a national working group landscape level protocol in 2024 and 2025. We really did our first statewide effort in 2025. In 2024, we focused it solely in the Great Basin. So we're doing a lot of work on the ground, trying to figure out where these jays are, what's going on. We're not quite there yet. We're getting there. We're starting to get a better idea of what we need to find out about these jays, but we're still probably a few years off. So one of the things that we decided to do as a state, and this is largely Division of Wildlife instigated, but it was also in partnership with Fish and Wildlife Service, is develop what's called the Conservation Agreement and Strategy. And this is different from a lot of conservation agreements or candidate conservation agreements with assurances. It's a lot different. This is a tool that's been used very effectively in Utah, but basically it's almost always implemented in areas to hopefully prevent an ESA listing. So keep that in mind. That's what our ultimate goal is. And so it's important, though, to keep in mind this is non-binding and it's non-regulatory. So participants can pull out of this agreement within 30 days of written notice. So it's entirely voluntary. Essentially, this is a document that says we are going to do good things for whatever species we're working with or working on, but it doesn't necessarily bind the agency to do that. So if you're sitting there and you're hearing, we're entering into a conservation agreement strategy, how's that going to change things? It will probably largely be a set of guidelines or at least a set of suggestions on where we go when possible. And there's 2 parts to it, as the name implies, the agreement and strategy. The agreement portion, basically, you're just pulling together all the entities that have authority over the species, as well as the threats and their habitats. And so basically it's saying that these entities will work within their authorities voluntarily to consider the needs for the species and address the threats. And we're at a point where we're just starting to wrap up the agreement now and entering into the strategy, which is where kind of the bulk of the work gets done. And that's where we're essentially defining some objectives and strategies where we can go out and ultimately do good things for jays on the ground. It's an adaptive process, though. So as new, and this is really important for jays because there's still a lot we don't know, as new information becomes available, we will amend those strategies. There's a lot of pros and cons of this. It has been very effective in preventing ESA listings. We pulled together a lot of great partners, and then it's been shown to improve the species status in almost every single case that we've implemented them. Cons, it's very time consuming. I'm entering year 2 of this process. I'm just about ready to wrap up year 1, and we're just kind of pulling together that agreement. And its focus is funding on one species, which is always difficult to do when you talk about native species funding. There's just not a lot of it out there. This is a big, busy slide. You don't have to read it all, but we have a history of using conservation agreement and strategies in Utah. But what I want to point out here is that they have largely been focused on things like fish and insects and plants and invertebrates. So it focuses on things that are relatively sedentary or confined to one watershed. This is the first time that I know of that anybody in the country essentially has focused a conservation agreement strategy on such a wide-ranging species. This process is only focused on the Pinyon Jay in Utah. There is a region-wide effort that's going to get started here relatively soon that will be informed by our process. But what I want to point out here is all of these species, and I didn't bother to count how many there are, but there's a lot. All of them were found not warranted by Fish and Wildlife Service for protection under the ESA after the signing of the conservation agreement strategy. Doesn't mean that'll happen with the Pinyon Jay, but that's the hope, that we can come up with a list of good things that we're going to do for Pinyon Jays. So the partners that we're working with, Fish and Wildlife Service, obviously, DWR and DNR, Trust Lands or SITLA, PLIPCO, which if you're not familiar, the Public Lands Coordinating Policy Coordinating Office, essentially the governor's office, Forest Service, BLM, DOD, NRCS, and NPS, National Park Service. So there's a lot of, this is not an easy effort. There's a lot of agencies, and we're trying to pull together all of these folks into one virtual room and get them to decide on things. And it's been tough, but it's been an interesting process for me. I'm out of my comfort zone, but I'm fine. I enjoy it. So I'm not going to read through all the objectives, but we are at a point where we're setting goals and objectives. Our goal is really simple: safeguard the long-term persistence of Pinyon Jays in Utah. And then we have a lot of objectives along the lines of restoring and enhancing habitat through restoration efforts and developing management actions to guide land managers is a big one for us. Identifying limiting factors. Oh, come on. That was beautiful. And then implementing surveys and monitoring protocols to assess population status. So we have objectives that we've defined, and we're working currently on the strategies. Our strategy, we just kind of went through some biological resource use threat that we're talking about last week, and in this upcoming week, we're going to start this fun process of talking about both fuels treatments and habitat treatments and see what we can do in those arenas. So that'll be an interesting conversation, I'm sure. Timeline, we convened in July of 2024. The agreement is nearing completion as of this month. Hopefully we can get signatures on that agreement and move forward. And then we began the strategy this month, and we're hoping for a completion in early 2026. And again, this is voluntary. We are working with folks in all of those respective agencies as well. So with that in mind, I am happy to take any and all Pinyon Jay related questions. If you do have specific questions about treatment areas, you're always welcome to contact me, or you can contact the conservation bios in your region with the Division of Wildlife. They're probably the best initial line of contact, and then you can come to me. So, yeah, Buck.
How often do they use juniper over pinyon?
That's a really good, for nesting or in what context?
I'm not a biologist. I'm just curious. So
broad. As far as nesting, it seems to be about 50-50. They'll use either or. They will use areas that are dominated by juniper as well as dominated by pinyon. So I don't think I have a good answer for you yet. We've actually seen in Idaho where there's relatively few pinyon pines, they will use areas exclusively dominated by pinyon or juniper and actually collect and cache juniper seeds, which is new to me. So. Yeah, so juniper component doesn't seem to be either a positive or a negative in their presence.
Scott, you'd shown an incredible amount of success, it seems, that the CAS brings to a number of species.
Yeah.
Would you say that there was adequate science regarding those species that enabled the CAS? And do you feel that the Pinyon Jay has enough science to support the CAS?
It's a really good question. I don't think I can speak to the previous efforts because I wasn't a part of them, and I really don't know much about mollusks and some of those insects. So I would say probably the data is still lacking on some of those species because they are so relatively understudied. In terms of Pinyon Jays, it's weird. We know a lot about Pinyon Jays, but we know very little because we started relatively late on this process. I think we know enough to make some really solid recommendations, management recommendations, but we're also not going to be afraid to say a strategy may be we need to focus more efforts on data gaps. We need to pour more money, more time and effort into figuring out nest success in and around treatment areas, things like that. So I think we're being realistic, and we're certainly not going to make any broad recommendations that we don't necessarily have the knowledge to back up. I don't know if that answers your question, but okay.
Hey, Scott.
Hey, Clint.
Are there any density dependent things happening when a flock size gets small enough, like they're not breeding, they're not nesting, or that flock kind of disperses and joins other flocks? Or
So some of the more interesting things that we've seen from some of the telemetry data that's taking place with the PhD students is movement away from flocks during the breeding season, like large distance movements. Like there was one that went from New Mexico to Vernal, right in the middle of breeding season. So that it's possible that that's happening. We don't have the data yet to support that. I would imagine there is probably a threshold at which they hit, and these flocks do come together at different times. You probably do have mixing of flocks, but I think it's too early for us to say, density dependence and the impacts on that. So that's a really good question. Yeah.
Plenty of time for questions, so anyone else? Brad?
Yes, Scott, can you give us a feel for what you might give for guidelines or thoughts about guidelines for doing treatments in some of these areas where we know colonies might exist? Are we looking at buffers, complete avoidance, things like that?
Yeah, that's a really good question. So we don't have data at this point to suggest. Obviously, okay, I will back up. Treating a colony during the breeding season, that's a no-no, right? Like that's a violation of the Migratory Bird Treaty Act. You're going to take birds. Like if you go in and treat a colony and cut down trees when there's an active nest, obviously we know that's bad. What we don't have data on at this point is to suggest what happens. So if you're doing a treatment in the fall, or you're doing it in let's say really early spring before they're breeding, we don't have good data at this point to suggest what happens if you treat a colony outside of the breeding season. So and I guess I'll back up. There have been a couple of studies that have looked at that in places where there's adequate habitat and colonies have been either lightly thinned or have actually been cut in to some extent. They've seen birds move adjacent and kind of stay in their same colony area. In Utah and Colorado, anecdotally, we're starting to see that colonies are probably a little more plastic than we realize. They're not as static, which is both good for management and also terrible for trying to avoid them, because if they're moving around year to year, it makes it really difficult to avoid those colonies. So as of yet, we're not making any official recommendations on if we know there's a colony, don't treat it in the off season, because we just don't have the data to do that. I know BLM in a lot of cases has not done that because they are getting litigated and they're getting a lot of attention in the NEPA process. So if there are known colonies, they're oftentimes avoiding them just from public comment. From a scientific standpoint, it's hard to say. I guess my recommendation, if you have a known colony, the safest bet is to not treat that area, right? Because there is a potential negative impact. And we just may not have discovered that yet. But my hunch is that if we have adequate habitat and a colony is treated outside of the breeding season, they probably will just move their colony. So that's not a good answer. I don't have any good recommendations for you at this point, but that's something I'm very curious about, and I'm pushing hard to try and get that research.
Add to that, Brad, that's the next part of the process, and I think that's going to be the difficult part of the process. Myself, Danny Summers, there's some habitat folks in that room, and so I will say, we as the group, we all went on a tour last year, and to me, it surprised me that by the end of the tour, we could all kind of point to an older pinyon juniper treatment that had kind of grown up, and we had more agreement than I thought we would have when it came to how valuable that treatment could be for Pinyon Jays. So I don't think we're as far apart as you think we are.
Yeah, I agree, Tyler. I think that's a really good point. We have a lot of habitat folks in the room. I think we're kind of coming to consensus. I mean, the one thing I can say, we've determined heterogeneity is good, right? You have diversity, both age and structurally, in pinyon juniper woodlands, as well as grassland and shrublands within their home range. That's good for pinyon jays. There's probably a threshold where if you remove too much pinyon juniper woodland, then they might leave that area. But heterogeneity is good. Treatments in general, I'm not adverse to pinyon juniper treatments in any way, shape, or form. I think anyone who's talked to me knows that. I think there are ways they may be able to be improved, and some of those may come out in the conservation agreement and strategy. But by and large, I agree with Tyler. I think we're getting to a good place.
Do you have any recommendations for monitoring, like pre-planning monitoring, pre-treatment monitoring? How many years? When should the monitoring be?
Yeah, that's really tough because we're just starting to learn what's taking place with these jays moving around. Obviously, colony fidelity is a big one, right? Like we want to know how tightly they stick to their colonies. And if we can show that treating a colony outside of the breeding season is bad for them, then obviously that might change our recommendations. Just given the nature of when these birds breed, you need to be able to probably monitor at least probably a year or so before treatment to get a good sense, and that's assuming the colony doesn't move. Colony's we focus so much on the colonies too, and I think we're starting to come around to realizing that like foraging areas are important, caching areas are important as well. I'm speaking from a colony perspective. I would say there is a protocol that has not been formally adopted by Utah or even the National Working Group. There is a monitoring protocol that's based off of the landscape level protocol. I believe that may be on the National Working Group website, which is, if you just search Pinyon Jay National Working Group, there is a monitoring protocol on there. That's a clearance protocol. But really, I mean, if you really want to find out what those birds are doing on a landscape, you really need about a year or two of kind of pre-monitoring to figure out what's taking place because they move around so much within their home range. For the record, I'm not advocating that we do that in all the treatments. I'm just saying if that's what you want to do and you want to monitor for jays and figure out what they're doing, it really does take about a year or two to kind of figure that out. Does that help? Okay. Bach, did you have one more question?
With the amount of pinyon juniper encroachment occurring, what seems to be the driver of the decline?
That's a really good question. There's in the petition, obviously, pinyon juniper management was cited. Drought, climate change, even West Nile virus as a possible factor was cited. My feeling is we've seen with a lot of climate change, we've seen a lot of drought and a lot of change in mast production. Production of mast in pinyon pines is incredibly important for jays. It is like the #1 driver in whether or not they're going to breed in the following year. And so we've seen a lot of variability and a lot of change in mass production, and that's anecdotal. There are some efforts in the forest inventory analysis to quantify mass production in pinyon pine, so hopefully we'll get a better feel for that. But I really feel like that's the biggest driver at this point is change in mass production and just ultimately drought and climate change. But that's partially my opinion, but yeah.
Do you have an idea of how thick, if woodlands get to a certain canopy cover per se, do they not use it? It's like, where does that line?
Right.
I know they don't use the real thick infield stuff,
Mm-hmm.
and I think that's got to be one of the reasons for the decline in Utah, especially. So, kind of, where's that line?
Right.
Because they use the periphery. So, I wonder if you have an idea.
I don't have an idea. I can visually tell you, but I don't know that I have like we haven't really quantified it yet, and that's something that hopefully we can get at with some of these PhD research projects that are taking place. You're not wrong though. If infilling doesn't seem to be good for pinyon jays, and I think we've seen an increase in pinyon juniper right at the same time we've seen a decline in pinyon jays. So it's probably more a quality issue than quantity. I would ultimately like to look at potentially the impacts of even doing some treatments and thinnings for pinyon jays. And not necessarily, we're not quite there yet, but we're maybe at the cusp of being able to do some of that. I don't have a good answer for you. Like, we need a tree density of X number of trees per. We're not there. But I think that might exist, and it probably varies by geography as well. I would imagine the Great Basin may be different than the Colorado Plateau. Yeah, Kevin.
I guess the other gorilla in the room, overlap with sage grouse and recommendations in that.
They love each other, coexist. So I hear this a lot, and it's like one of the big things. Like it's like we don't even want to talk about that sometimes, but I don't think that the two are like mutually exclusive in any way, shape, or form. I think Pinyon jays need shrublands. They need, it doesn't have to be sage per se, but they need openings for, caching and also retrieving those seeds. And they use those ecotone edges. So I think we're hopefully going to reach a happy medium where we can manage for both species in the same area, in the same landscape. I don't get a sense that we're going to ever get to a place where it's just butting heads. It either has to be sage grouse or it has to be pinyon jay. They co-evolve together on the landscape. We can get there. I don't have a good answer for you other than that. Other than I'm optimistic that we can manage for both in the same area. I know there are some conflicts in terms of removing pinyon juniper woodland or encroaching pinyon juniper in areas where there are sage grouse. But I don't necessarily know that's in direct conflict with pinyon jays per se. It's often cited that it could be, but I'm not getting a sense that it necessarily is.
Okay, great discussion. Thank you, Scott.
Yep.
If you've got other questions for Scott, grab him during the break. I'm sure he'd be happy to talk pinyon jays because that's his job now. Okay, we're going to move into our first break. There's still coffee and drinks and some snacks in the back. Feel free to partake. We'll get started again at 10:40. All right, folks, let's start finding our seats again, and we're going to get started. Okay, we're going to get started here in a few minutes. Let's start to wrap up our conversations and find our seats again. Okay, we're going to get started. The next up, we're going to hear from Paul Thompson. Paul was not able to join us here in person, so he's recorded his presentation, and then after the fact, Eric and I get to try and answer questions for him. So let's hear from Paul.
Well, again, good morning. For those that don't know me, my name is Paul Thompson. I work with the Utah Division of Wildlife Resources in our Habitat section in our Salt Lake office. I help coordinate our Wildlife Action Plan work, which includes comprehensive revision that we're going through right now, and that's what I'm going to give you an update on today, but I'll also talk a little bit about another program that I help administer called the Species Protection Account, and that is our native species funding source to help us implement the Wildlife Action Plan. I do apologize for not being able to attend the conference today in person. I had some conflicts that prevented me from coming down today, so I regret that. But let's get into the presentation, and I'll give you an update on where we're at with the Wildlife Action Plan comprehensive revision. A little background to start, just make sure we're all on the same page. What are state wildlife action plans? They are Fish and Wildlife Service required plans, and states have to have them approved and finalized in order to receive federal state wildlife grant funding. So each state does have a wildlife action plan in place. They are 10-year strategic plans that align native species conservation efforts. In Utah, we consider them being a roadmap to prevent additional Endangered Species Act listings. This will be evident through the presentation this morning, but I want to just highlight this, that the Utah Wildlife Action Plan is not just a DWR plan. This is a partner plan for all working on native conservation species efforts in Utah. So I mentioned that these wildlife action plans are Fish and Wildlife Service required documents. They also have 8 elements they're looking for in these documents. So first, they want to see what species are in need of conservation attention. What species should we be focusing on as a state to conserve in Utah? The second element is the extent and condition of the habitat for those species. The third element are the threats to those species and their habitats. Then moving down the list, what are the conservation actions that will be implemented in the plan? How will we monitor plan effectiveness? How will we review and revise the plan into the future? And then the last 2 elements are how will we involve our partners and the public in not only the revision of the plan, but the implementation of the plan. So our first wildlife action plan in Utah was submitted and approved in 2005. And again, these are 10-year plans. So we revised the plan and submitted, and we have a 2015 wildlife action plan, which is actually the plan that's in place right now until our 2025 plan is finalized. But in preparation for that 2025 plan and the revision, We held a partner meeting in the spring of 2022 that really kind of outlined our vision on how we were going to go through the process of revising our wildlife action plan so that we could submit it in October of 2025 to the Fish and Wildlife Service. Through the course of the last 3 years, the revision process, we've had two primary committees helping with the Wildlife Action Plan revision. We have a core team, which is really our partner team. It includes all of our native species conservation partners that have chosen to participate in this plan revision, and that's over 35 partners. So this group meets quarterly. They began meeting in January of 2023 and will continue to meet at least through October of 2025. And really the goal is for this group to provide a high-level direction on that plan, on plan revision through time. We really relied on core team members to take information back to their agencies and organizations and keep them updated and get additional input. The core team did review chapters as they became available, and a final draft went out this spring, and it went to the core team and all of our subcommittees for review. Then the other subcommittee is a DWR internal team, and this team also meets quarterly, and really it's just to make sure that the Wildlife Action Plan revision was meeting our agency needs and that we are effectively implementing the current plan in its form. We also had a series of revision subcommittees through the course of the Wildlife Action Plan revision. Some of these groups met once, others met over 10 times, really depended on when they felt that they kind of hit that target on what their charge was as far as information that needed to feed into our revision. So these subcommittees included an agency organization integration subcommittee, which is really just a discussion we had with all of our partners on how they use the Wildlife Action Plan, how we could make it more useful for them in the work that they do. We had a plant insect integration subcommittee. Plants and insects were new to this 25 plan, so we wanted to make sure they were integrated throughout the plan. We had a landscape and regional focus subcommittee, species of greatest conservation need subcommittee to help us decide what species should be our primary focus in the 25 plan. We had an aquatic key habitats subcommittee and a terrestrial key habitat subcommittee that revisited our key habitats to make sure they still met our needs. We had a water subcommittee. Water is very limited and critical to all wildlife in Utah, as we know, and I wanted to make sure we highlighted this need of water adequately within the 2025 plan. We also had a climate adaptation subcommittee and a habitat connectivity subcommittee, and I've highlighted the habitat connectivity subcommittee in red. This is one group that will continue to meet beyond when we turn in the 2025 plan. Have a lot of needs still on how to address connectivity needs for our species of greatest conservation need, and this group's going to try to tackle that into the future. So what were some of the highlights from the 2025 comprehensive revision, or what are some of the new additions to the plan? I mentioned we did a full integration of native plants in need of conservation attention in the 2025 plan. Also, integration of native insects in need of conservation attention. We added a chapter this year in this plan for climate. This includes the development of climate refugia. Worked with Dr. Ed Hamill at Utah State University to help develop huck wells within Utah that have high densities of our SGCNs and key habitats and aren't as susceptible to a changing climate. So it kind of gives us some ideas on some areas of the state where we can really focus some efforts and have long-lasting benefits. We added a regional collaboration section in our partners chapter. And we helped organize this plan like other state wildlife action plans are doing by EPA level 3 ecoregions. And these are really just areas that have similar species, similar habitats, similar threats to those species. So as we're working more on a landscape and regional scale, our partner states that we work with our swaps can talk better by organizing by these level 3 EPA ecoregions. So other highlights, we really took a deep dive on our species, and this is a pretty final draft list of where we landed for our 2025 plan. We have 8 herps. These are amphibians and reptiles, 22 fish species, 26 mollusks, 14 mammals, and 23 birds on our SGCN list. So this was the group of species that were in our previous plans. And then in addition, this year we added plants and insects. We have 145 plants as SGCNs and 16 insects. I think the total is 55 species. We also have a subset of our SGCN list that's new this year. We call these the species of greatest information need. So as our SGCN subcommittee met, we have a rubric in place that we run species through, and they need to qualify in order to be placed on our SGCN list. Some of those species in the past have been put on our list mainly due to data deficiencies. And we don't feel that these really are truly species that are declining necessarily on the landscape and maybe aren't in need of conservation attention. They really are just species where we need additional information to understand how they're doing on the landscape. They may need a conservation attention. Once we look more for them, they may drop off the list. So this SGIN list sorry, I had was trying to kick me off because it didn't know if I was still there or not. So, So this SGIN list is, I think, a great way for us to understand species that have taxonomic uncertainty, distributional uncertainty, we don't know where they occur, or ecological uncertainty. And we can pay attention to them, get some additional information, and see really where the conservation need is. We also looked at our key habitats. We had subcommittees looking at those. Our terrestrial key habitats didn't change a lot, where our aquatic key habitats, we put a lot of effort in to make sure that if it's wet, it's probably important in a key habitat. So carryovers on the aquatic key habitats, we had wetlands, streams and rivers, and lakes and reservoirs. And then new to this plan are springs and saline lakes. And this is really an emphasis on the Great Salt Lake ecosystem and its importance to all of the species that rely upon it. So what are the next steps in the WAP revision? First of all, I'd like to thank all of you that have helped with the comprehensive revision. It's been 3 years, a lot of effort. A lot of partners have put a lot of time to help us make this next plan that much better, and it will be that much better because of all the input we got. So thank you for your help. Really, our final draft was out for review this spring. That review period ended on April 28th. So now we're going to take the next few months to address partner comments. We'll take a few months to do our final editing and formatting, and we should have a final plan ready to submit by the end of September or no later than October 1st to the Fish and Wildlife Service. At that time, the Fish and Wildlife Service will go through a review process, so we really probably won't have an approved final wildlife action plan until sometime in 2026. One thing I'd like to do, we go through this really large effort to go through these comprehensive revisions of wildlife action plans, and when we're done, we just take a big sigh and pat each other on the back, and all of a sudden we have to come back together in 7 years for the next comprehensive revision. But while we have this momentum within our partners, I want to keep some level of annual coordination meetings so that we can make sure we're effectively implementing the plan and identifying areas that we need to work on either a minor revision or our next comprehensive revision and address and make our plan better. But even though we have a draft plan out, it won't be submitted until fall, won't be approved until 2026. We need to start using the information in our 25 plan. There's no reason not to. And we're already doing this within DWR. So I'll make the plan available this summer on a Google Drive, and we'll spread that around to those that have interest in using it. And within DWR, I've already done this. So we're using the draft plan in the development of our habitat management plans. So we're using the new SGCN list, the new key habitats list, and the threats to those species and habitats. As we develop these plans, if we're using the old information, they're outdated really before they're even final. So we're using it, and we're just citing the plan as draft at this point. And what I want to do this fall is work with Tyler and the WRI team to help integrate the new Wildlife Action Plan species list, habitats, and threats into the WRI. So then this information should be updated and available when you are submitting your projects for FY27. So I want to just change gears here just a little bit and talk about the Species Protection Account, or SPA. This is really the Native Species Fund that helps us implement the Wildlife Action Plan. It's been great to have in place for the last 25 years, but we've been in need of additional funding through time. And this next year, our FY26 is a very tight year. We weren't able to fund as many projects as we had hoped to. We did get some additional funding the last 2 years from the legislature, one-time funding in FY24 and FY25, which allowed us to really put money into more projects. But this year was tight, and we weren't able to fund too many projects. But there is a bright light at the end of the window for Species Protection Account. In the 2025 Utah legislative session, House Bill 378 was passed, and this established some new revenue streams for the Species Protection Account. There's going to be a tax on certain new wind and solar projects as revenue, and also an annual assessment on renewable energy parent entities. So for FY27, or at least by FY28 and into the future, we are hoping to see maybe an additional $5 million in Species Protection Account funding. So I really encourage all of you that are working on projects to look for those opportunities for benefits within your project area to benefit and implement the Wildlife Action Plan. What we've been doing has been great, but there's going to be some additional money that we can put towards these projects. The WRI is an amazing tool, especially for Wildlife Action Plan implementation. A lot of my counterparts across the country are trying to figure out how to align their partners to work on the right species, the right habitats, and alleviate the right threats. And all of that information is in the WRI, and every project that is submitted through the WRI considers Wildlife Action Plan implementation, so it can get those additional points. And now we'll have some additional funding to put towards those projects. So it's really an exciting time, and let's continue to work on Wildlife Action Plan implementation in all of the projects that we do. So with that, I'd like to thank you. I have my contact information here. Drop me an email, send me, or give me a call if you have some specific questions. Again, I apologize for not being there in person, but Eric Edgley and Tyler Thompson are here today, and they can help answer some of the more general questions. So with that, thank you.
Okay, any questions on the Wildlife Action Plan?
Tyler, do you know if the wildlife habitat analysis tool is already incorporating the 2025 SGNs and SGINs?
Where's Maeve? That's a Maeve question. I don't know that. Do you know, Eric?
I believe so. Yes. Yeah, we've already incorporated that into the web tool. So yes.
I'd be interested to understand how wildlife action plans and the agreements that Scott Gibson spoke of work together to support species of concern. I noticed that the Pinyon Jay is in the UAP list. So how do they work together? What's the interplay?
Well, I think the document really does guide it. I mean, it has within it the strategies and threats that we're supposed to be addressing with these projects. He also mentioned, the program within the agency that is getting a lot of additional funding that'll help produce more results with those species as well. So they're integrated pretty closely. Any other questions?
So yeah, I have one.
Maybe just back on that one really quick. When we look at the wildlife action plan, it's kind of a high-level plan that includes Pinyon Jay and lots of other species. The work that Scott's working on and the conservation strategy, that's the really detailed end of it, and how to implement that, conservation actions for an SGCN. So it's another way to look at it.
Okay, one more question, then we got to move on.
My question kind of ties into that, because Pinyon Jay is listed as one of the species of conservation concern, but pinyon forests or pinyon juniper forests are not really one of the key habitats in there. That is a focus of the Wildlife Action Plan. So will the 2025 plan elevate pinyon and juniper, or at least pinyon, as one of the key habitats that is focused on in the plan?
Go ahead.
That's a good question. I don't know if Scott has any more information on that, but yeah, we'll have to look at that one and see. Yeah, I think that could be, the comment was made that I think that that's lumped together into a larger key habitat.
I think it is, and I can't remember what the category name is called, but Tori's right. I think it's been lumped in with a different habitat category. And I don't know that the presence of Pinyon Jay as an SGCN would necessarily elevate that, but it has been included in that way. So, and really quick too, we also did use the SGCN. We have to do a threat ranking for SGCNs to come up with the S rank for them, and that threat ranking was used a lot in the conservation agreement strategy. So.
Okay, if you've got other questions, Eric and I are here all day, so just come up and we can discuss more about the habitat plan. So next up, the next three presentations are covering WRI sponsored research. So first up, we're going to hear about hydrological monitoring of watershed restoration from Emily. These first two are from UGS. Come on up, Emily.
Hi everyone, my name is Emily Jainarain and I'm a hydrogeologist with the Utah Geological Survey, Groundwater and Wetlands section. I'm going to be talking about our WRI project and giving some updates on it. It is titled Hydrologic Monitoring of Watershed Restoration. And before I start, I want to give credit to our program manager, Hugh Hurlow, who's sitting over there. He has put in a massive amount of work towards these projects, from writing proposals, doing background research, figuring out methods, setting up equipment, and doing a ton of field work. Additionally, pretty much everyone in our groundwater and wetland program has at some point worked on this project or currently is, and so it's very important to our program. Okay, so we have 5 kind of projects within the WRI project. 3 of them are pinyon juniper treatment areas and 2 are stream restoration. I'm only going to talk about one of the stream restoration projects because my coworker Trevor is going to talk about Vernon Creek in the next talk. Disclaimer that I got all of this information from the USU Extension website. I'm not an expert in pinyon juniper woodlands, but as many of you probably already know, they are expanding rapidly around Utah in places where we, I guess, weren't expecting to see them. And they are threatening sage grouse habitat, amongst other things. And we believe the possible reasons that they're expanding pretty rapidly are due to climate change, livestock grazing, and fire suppression. Again, USU Extension website, these are their pictures. This is kind of showing the progression of PJ dominance over time. So in phase 1, the perennial grasses are dominating, and there are some PJs and plenty of sagebrush. And then in phase 2, the sagebrush understory is thinning, and PJs are starting to take over. And by phase 3, there's total PJ dominance and little to no sagebrush. So some of the potentially adverse impacts of pinyon junipers include increased fuel loads, decreased ground cover, increased erosion, and decreased biodiversity. Potentially positive impacts of treatment include decreased fire loads, restored sage steppe flora, increased spring and stream flow, which is what we're interested in monitoring, and increased wet meadow habitat. So the UGS kind of saw this as an opportunity to study the hydrologic response of these pinyon juniper treatments. So the way we set this up was a paired basin approach. Most of our, I guess all of our pinyon juniper treatment projects are set up this way. We monitor the watershed where the treatment occurred, and then we find a similar watershed nearby and monitor that area as a control. And then so we monitor 2 to 3 years before the treatment occurs and try to monitor at least 2 years after. By the end, we will estimate hydrologic changes and account for climate fluctuations. Okay, so starting with Tintic Valley. Our study area is located in the Sheeprock Mountain Sage Grouse Management Area. It's in that southeast corner. This is our very first pinyon juniper treatment project that we started monitoring in 2017. There are 3 sub-areas: Mud Springs, Death Creek, and Railroad Springs. The treatment occurred above Mud Springs in 2021, and we've kind of wrapped up most of our monitoring because we have plenty of data. But we've continued monitoring flow measurements at certain locations. And so throughout that time, we monitored spring flow, stream flow, soil moisture, vegetation, and shallow groundwater levels. This is a great visual of the treatment. So the top photo is before treatment, pinyon juniper dominance, and the bottom photo is post-treatment where it's been removed. Railroad Springs is one of the sub-areas of Tintic Valley. We monitored 11 springs there starting in 2018. The treatment occurred in late 2019, and we wrapped up monitoring last year. So again, we monitored spring flow, shallow groundwater levels, and stable isotope composition. We are in the process of processing and analyzing that data, and so hopefully we'll have results soon. Next is Montezuma Creek. We monitor 2 tributaries of Montezuma Creek, including Boulder Creek drainage, which is the control area, that top area of the map, and then Coal Bed Creek drainage, or it's another tributary, and that treatment occurred above Coal Bed Creek just a couple months ago. We started monitoring there in late 2018, and we monitored shallow groundwater levels, installed temperature loggers and soil moisture probes. And yeah, so we suspect that if the treatment allows for or results in more stream flow to Montezuma Creek, then that could improve the water quality because Montezuma Creek is impaired for selenium. Okay, and Grouse Creek. The Grouse Creek Mountains provide habitat for sage grouse, boreal toads, and the least chub. The DWR works a lot in this area. They would like to see these habitats improve, improvement in groundwater discharge to springs, grazing quality, and reduce wildfire hazard. We are in this area monitoring changes in spring flow and groundwater levels. We've split up the Grouse Creek area into two sub-areas, the southeast sub-area and the southwest sub-area. The treatment in the southeast occurred in 2019 and the southwest, hopefully by the end of 2025. And the red boundaries are the treatment areas, the blue boundaries are control, and so we have those control and treatment areas within each sub-area. Let's see. And same kind of idea, if the treatments result in greater stream flow, then that could mean more water going towards these habitats that we're interested in. Here are just some nice pictures from Grouse Creek. It's a really, really beautiful area. On the left is Bovine Springs. In the middle is Willow Springs. There is a fire there, and the DWR noticed an increase in flow, and I think that kind of prompted this idea that there might be more water after the treatments. And then on the right is one of our flumes in Willow Springs Canyon. The flumes collect water level measurements every 30 minutes, and that is directly correlated to flow. So we go to Grouse Creek monthly for most of the year, and we download this data every couple of months. Okay, and finally, our stream restoration area, Three Creeks. This is a managed grazing project. It is located in Rich County, near Randolph, south of Bear Lake. It consists of private and public land that is used for grazing. And so the stakeholders in this area came together and came up with this Three Creeks Grazing Allotment Consolidation Plan, which consolidates herds of cattle and allotments to allow for greater flexibility in grazing practices. So we saw this again as an opportunity to study the hydrologic response to these changes in grazing practices. We hypothesized that stream bank damage and kind of the compaction of soil from the cattle might disrupt the natural connection between the stream and the adjacent aquifer, and thought maybe the managed grazing could restore that connection and kind of decompress the soil. So our goal is to monitor surface water and groundwater interactions as the soil health metrics hopefully improve. The way we did this was we paired sites within and outside of existing exclosures, and our study areas are shown in this map. The north one is the Middle Otter Creek study area, and then the Big Creek study area. This is some pictures of what we were seeing in Three Creeks, with, on the left, a point bar that is in good condition within the exclosure, so not being grazed. In the middle, it's a trampled meander bar outside of the exclosure, and you can see where the cattle have trampled that grass and soil. And on the right, a slumping stream bank and a grazed reach. So this is our Middle Otter Creek study area. The pink boundary is the exclosure. You can see we have those sites inside the exclosure and then just outside the exclosure. Same thing with Big Creek, sites inside the exclosure and outside. And this is how we have our piezometers set up to measure water levels. We have an in-stream pressure transducer in that PVC that you can see inside the stream. And there's also a staff gauge. And then we take flow measurements monthly. Those piezometers are perpendicular to the stream also have data loggers that we download every few months. Bird's eye view of the same thing. There's the stream and then the perpendicular transect of piezometers. And then we also have a D site on the meander. This is just an example of what we see when we download the data from these transducers. This is nicely cleaned up. It looks much worse than this when you first download it. So this is Big Creek outside of the exclosure, and then on the right inside of the exclosure. And the blue is closest to the stream, red is next closest, green is furthest, and the purple is at the meander. And then this is the same kind of thing for Middle Otter Creek. And so you can even see in 2023, it starts off way higher than 2022, and that's the big snow year, and so we'll take that into consideration in our analysis. So with this data, we'll use statistics to look at trends and patterns within and between seasons, from well to well, site to site, inside the exclosure, outside of the exclosure, just until we find some results that are significant. And if you want to know any more information on these projects, you can visit our groundwater data hub that we've been working on for the last 2 years. It has tons of information about these projects, and then you can even see our manual measurements on there from each site. It should be updated in the next couple weeks with this last year's data. Thank you.
Okay, questions? Any questions for Emily? Okay, thanks, Emily.
Thank you.
Okay, next up we're going to hear about BDA work on Vernon Creek from Trevor. This is the second part of the UGS WRI funded study.
Okay, like Emily, I'm a hydrogeologist with the Utah Geological Survey in the Groundwater and Wetlands Program, and I'm going to take a little bit of a deeper dive into one of these restoration projects. So I'm going to talk about the hydrologic response to beaver dam analogs in Vernon Creek, Utah. So the problem that we can see here in this photo is stream degradation in the form of channel incision, which lowers the stream bed and disconnects it from the adjacent floodplain. This causes a lot of problems. The ones that, as a hydrogeologist, I'm most interested in are flashier stream flow and increased peak flows, and then decreased base flow and groundwater storage in that adjacent sort of riparian aquifer. There's a lot of other problems that have been pretty thoroughly studied and documented, so I won't get into those right now. But you can see in the photo that there's like 15 feet of disconnect from this historical floodplain, and then even within the modern floodplain, there's like 1 to 2 feet of distance between that ground surface and the channel. So there's a lot of room for improvement. So beaver dam analogs, for those not familiar, which I hope everyone in this room has at least heard the term, is a process-based restoration method that just mimics nature and puts in human-made fake beaver dams in streams to slow the flow of water, initiate debris accumulation, by slowing the flow of water, increase sediment deposition, and basically rebuild that channel back up so that it's closer to a natural stage. And you can see several BDAs in this photo here. And so from a hydrologist perspective, this buffers stream flow, and it increases that groundwater exchange with the adjacent aquifer. And again, there are a bunch of other like well-documented benefits to this restoration method that I won't get into. So just sort of for context, the solid blue line in this image would be representative of what the current stream channel looks like. And then by putting in these BDAs, we're raising that stage or height of stream, and we're increasing the gradient between the stream and the adjacent groundwater. So we're allowing water to flow outward into the banks as storage. So part of the reason for this research is that there are still lingering concerns, primarily from downstream water users, about the quantity of flow in the streams and the timing. If you see pooling behind dams, you see the reduction in velocity. That can sometimes translate into this notion that the BDAs are prohibiting stream flow downstream. So we want to collect empirical data to determine whether or not that's taking place. And so we're looking at stream flow and we're looking at groundwater measurements. So this is our study area in southern Tooele County. Vernon Creek is a second order stream. It's also within the Sheeprock Mountain Sage Grouse Management Area. The watershed is outlined in red here. You can see, zooming in, Vernon Reservoir, and then Vernon Creek above that, and Little Valley Creek, which is a major tributary to Vernon Creek. Also of note is there's a USGS gauging station on the stream that we leverage data from pretty heavily for this study. And then higher up in the sheeprocks is an NRCS SNOTEL snow survey site that we're leveraging data from as well. So zooming in a little bit closer to the study area, so BDAs are shown as triangles here, and I'll note that in 2017, a bunch of BDAs were installed downstream of where we took measurements. And then the BDAs shown in yellow are the ones that were installed as part of this actual study. So like the paired basin approach, we're doing a paired reach approach where we have two reaches of the stream intended for BDA implementation, and then two reaches as control points. And so those were just left alone to provide baseline measurements. So we wanted to measure stream flow response to BDAs. So we have the USGS gauge immediately downstream of BDAs, and then two measurement points upstream from there. I'll mostly just talk about the USGS data because our upstream data is a little bit messy, a little noisy, and requires further processing to fully utilize. And then so within each of these white boxes is a setup of an in-stream monitoring device and then 2 to 3 shallow piezometers measuring continuous groundwater level data. So we collected baseline data for about 3 years prior to installation of the BDAs, and then 2 years post-BDA. So this is just an example of kind of the layout of one of these sites where we have a staff gauge within the stream to look at stream stage, and then we have 3 piezometers kind of along a shallow meander along the stream. And then you can see also the location of BDAs relative to those points in this treatment area. And then this is a photo of that same area prior to BDA installation, just to give you kind of an idea of what the site looks like. And you can see the extent of incision in this site as well. Okay, so thinking about some results, looking at USGS gauge data back to 1978, which is the period of record that we have SNOTEL data from as well. That's why I chose this time interval to look at, just to show what the natural variation of stream flow in this creek looked like over the past few decades. And then at the very end, you see two solid gray lines that represent when the BDAs were installed and then when they were also like repaired the following year. And if you see, there's a very high point in red. It's kind of difficult to see. That corresponds with that super wild mammoth snow year of 2023. So you can see this huge runoff spike and then increased base flows after that point. And the timing also unfortunately coincides with when we did the installation. So looking at the SNOTEL data from that site up in the sheeprocks, the median, the 30-year median is shown as this skinny green line here. And then most of the other data kind of clusters around that. And then 2023 just goes off the chart, and I believe this is more than triple the median peak snow water equivalent at this site. So that maybe sort of throws a wrench in the process here, but we'll keep looking and see what we can see. So what I'm showing here is maximum snow water equivalent for a water year plotted against the mean January discharge at that USGS gauge from the following year. So for the 2023 water year, then you're talking about January 2024 base flow. And so January discharge is like a good approximation for base flow that's unaffected by snowmelt or ET or any kind of processes like that. And so I'll point out also, oops. Okay, so the 3 years prior to the BDA installation were some of the lowest SWEs on record and some of the lowest mean base flows. And then when 2023 comes, you have this record-setting outlier, but it doesn't really move the needle in terms of base flow all that much. And then the following year, you have a slightly above average SWE and more or less median discharge. So there's a lot more to the story than just SWE and discharge. I think soil moisture is a factor that I need to dig into, but when you have a watershed that's just chronically dry for several years prior to a huge snow year, you have a lot of room for infiltration that doesn't translate into runoff. Okay, so we're just looking a little bit closer at our actual study period from about 2020 through 2024. And you can see that the timing of the BDA installation coincides with this falling limb of the snowmelt period from that runoff year. And then again, the next year it was more of a, quote, normal winter, but we're still also seeing the presence of that falling limb of the hydrograph during BDA installation. And so the takeaway here that I have is that I don't know for sure if the BDAs had an impact on the stream flow. I'm still working through trying to sort that out and remove the climate signal. But so far, that snow year has swamped any sort of signal from the BDAs that I've been able to discern. But this is still a work in progress, so I've got some more statistical tools to learn and hopefully leverage. So switching gears now to groundwater. We'll look at the control reaches first just to get an idea of how the system responded just naturally. So this is a control reach. The groundwater elevations are the 3 lines, and then the yellow points are just manual stream stage measurements adjacent to the piezometers. And so you can see that the system responded pretty strongly to that big runoff year, the big snow melt. And then I still need to run some statistics, but it's definitely elevated relative to the baseline data, but more or less back to somewhat of a normal state. And similar at the other control reach where It's in a lot greater connection to the stream, the groundwater is. And so you see that big spike and then back to somewhat business as usual. So this is just sort of for reference. More interestingly, looking at the treatment data, so T1, which we saw a photo of, is in somewhat of a connection to the local groundwater system. You see that big snowmelt signature, and then you can see very clearly when we put the BDAs in, the whole system responds very quickly and equilibrates within a few days, basically. And you see the same thing again. We go out there and do the repairs. And when I say we, I don't mean we as in me, because I didn't do any of it. Robbie Edgel back there, he did a lot of it, and his crew are responsible for the actual on-the-ground hard work that we're talking about. So thanks to Robbie for that. But you see this huge response, and again in 2024, and you see the same thing at our other treatment reach. Now this site has piezometers up on that sort of higher historical floodplain, and so it's much less connected to the actual stream stage. And so the opportunity for like a larger increase was present here. And so you see that big spike in the snowmelt, and it brings it back into phase with the stream. And so you have groundwater that's really closely connected to the stream stage for the first time in probably a while in this area. And then again, you see that big jump from the install and the maintenance period. Okay, so I have a few like simple metrics to kind of help explain what we're seeing here. So I'm looking at change in 2023 and 24, and so I'm looking at winter change and BDA change. And when I say winter change, I'm just talking about from the beginning of the water year to the day before BDA installation. And so from that big 2023 winter, you see a huge change across all sites. I mean, C1 on average, the piezometers increased by over 7 feet. T1 a lot less so. So you see that huge winter change. Then in 2023, the treatment sites, you see an additional, after it starts to drop off, you see an additional about a foot increase on average across the sites, and then no change really in the control. And the following winter, which was much more normal, you don't really see much consistency here. You see no change at T2, a little bit of a decrease at some of the other sites, a little bit of increase, and then a big jump when you repair the BDAs in 2024 of a foot or so. And so looking at, so now we kind of understand the magnitude of the increase. So I want to talk about duration of impact, I guess. So these metrics here on this table, what I mean by duration is from this elevation prior to BDA installation, how long through the season on average does it stay above that level before it drops back down to that level? And so on average at T1, it was 69 days in 2023 and 106 days. So that's 106 days of groundwater elevation above what it was prior, and that's 106 more days that you have this storage basically that can then feed back into the stream. And so for comparison, so looking at that same time period, if you look at that 69 and 106 days at the control reaches, how much does that actually change during that duration? And in 2023, it was primed to drop more just because it was so elevated from that big snowmelt season on top of the BDAs. But even in 2024, you're still seeing a decrease of a half to about a foot on average. So the ability of BDAs to divert water into the bank and then release it slowly over the season is inherent in this data set. So backing out again. So this, after speaking with Robbie, I realized that this map is missing a few polygons, but I just want to show the extent of BDAs in this watershed. So there are some further up here and then maybe like a little bit further up that I'm missing, but in general, most of the stream does not have BDAs on it. And so the impact of a BDA, how many of them do you need to truly move the needle in a measurable way to impact stream flow? I think from our data set, it's hard to say that you can really make a measurable impact. I think, so we installed 35 during that 2023 period. More work is needed, but my gut tells me that we're really looking at these smaller scale impacts that are superimposed on these like larger magnitude watershed scale processes that just kind of like swamp the signal. But on the other hand, we do see very obvious localized and relatively short-term impacts that are ultimately, I think, beneficial for the health of the stream without really having a huge effect on downstream flow in general. And so I've got some points up there that are just future work that I need to do to try to detrend some signals and run some statistics, but I also just have this photo of some of my lovely colleagues that I've been able to spend time in this area working on this project on. So yeah, any questions?
I guess I have kind of two questions. One, how much longer are you going to be studying this area? Are you going to be looking at long-term effects as well? And two, were livestock excluded from this area during the study?
Good question. So I would prefer not to continue studying long-term just because this project is maybe one of our first opportunities to actually, we're about to start year number 10, I think, of WRI monitoring, and this project is the first opportunity to actually publish something just based on the fickleness of looking at this kind of work. So I think I have enough to make a publication. We have our instrumentation still on site, and it still is actively collecting data. So if I wanted to, or if my boss over there tells me I have to, I'll keep monitoring, but I would prefer to move on to other projects if possible. I will say that BDAs in general are designed, well, they have a lifespan of maybe 1 to 5 years without, recurring maintenance. And I know that in some places where beaver isn't a, 4-letter word, actually reintroducing beavers into a BDA-built area can be a great way to actually keep that maintenance going and increase the beneficial effects of these structures. And I've already forgotten your second question. So grazing, yes, okay. There is grazing. So the study was on a mixture of private and public land, and so I can't really remember if there was any sort of pattern or timing on that we noticed. We would see when there was grazing present for sure, but yeah, it's definitely out there.
I guess to follow, would you take the grazing into account? Like if there was more grazing in the test areas than in sorry, my mind just went blank, on the control areas, would that make a difference in the groundwater? Have you taken that into account?
That's a great question. If we could get that data, it's definitely worth looking at. I have a feeling that just based on the land ownership dynamic that there was more grazing in the control areas. The treatment areas were on private land, and so I think there was maybe an agreement to not graze in there during the experiment, or not graze as much. But yeah, worth looking into, absolutely.
I have a question about water quality, and if any water quality data were taken to see if there were any differences between water quality above the treatment area as opposed to below due to the water filtration capability of the floodplain.
So we looked, the only real water quality components that we looked at were we measured temperature and conductivity, so a proxy for total dissolved solids. And we measured that in all the piezometers and at the flow measurement sites. So I haven't really had time to parse through that data, but yeah, that would be interesting to see if downstream of the BDAs had a lower TDS.
Okay, let's go ahead and move on. Thanks, Trevor. Okay, last up before lunch, we've got Devry here, who is going to report on the final WRI sponsored research project. This one's through BYU on megafire impacts on terrestrial and aquatic ecosystems. Devry. Oh, and she's got her BYU shirt.
Just for you, Tyler. So my name's Devry Tanner. I did a lot of this work during my PhD at BYU with Sam St. Clair, who was out of the country on a great study abroad, so he's not able to make it today. But we'll be discussing the research update on megafire impacts on the terrestrial and aquatic ecosystems. Aquatic is in parentheses because my PhD focused on the terrestrial aspects, so that's what we'll be talking more about today. The three main characters in the research are ungulates, or these large herbivores, deer, elk, and cattle mostly, fire, and specifically megafire, and obviously the forests that are impacted by these two. And we'll look at the herbivory and also the megafire impacts on multiple forest types that were burned. The herbivory regimes in Utah have been changing over time, and this study done from a few years ago showed that with increasing ungulate abundance, aspen regeneration is decreasing. And something important that this study found is a critical threshold of about 30% when meristems are the leading growth tip on saplings, and when 30% of those apical meristems are browsed, forest regeneration begins to be negatively impacted, and at 60% of regeneration, at 60% meristem browsed, forest regeneration begins to fail. And so with increasing ungulate abundance, tree regeneration can have some negative impacts. And specifically in Utah, wildlife populations have been increasing, which is awesome, but it also comes with different complexities that we need to be aware of. And livestock have also been increasing on the land at the same time as humans are taking away habitat for housing or other developments. And so with increasing unprecedented increases in ungulate abundance, there's also unprecedented impacts. And in terms of fires, the graph right here shows us with increasing fuel aridity, there's increasing forest fires. But what I want you to pay attention to is the red dots. And you can see these are the more recent years, and fires are larger in more recent years. And as fires are getting larger and larger, they can burn into habitats that aren't typically burned. And specifically here in Utah, we have a lot of aspen forests, aspen fir, at our high elevations, and those forests are adapted to fire, and they have the clonal regeneration, so that root system that stays after the fire to help them regenerate quickly. But when this fire came through, this is the Pole Creek megafire, if any of you remember it from 2018, it burned from those aspen forests down through the lower elevational oak maple and even down into the pinyon juniper and sagebrush. And when fires are so much larger, there's a lot more habitat is obviously affected, but also a lot more wildlife. And we're specifically today going to talk about how the understory is impacted by that megafire that crossed the 3 different forest types. And then we'll get into the forest regeneration and how those tree saplings are impacted not only by the fire, but by the herbivory that happened following the fire. And if you're not a plant person, we'll talk a little bit more about the intricacies of understory, but they're basically just the plants underneath the trees. This is a visual depiction of the different forest types. You can see they're elevationally separated. Aspen fir forests are our highest elevations. The oak maple forests are directly below that, and our lowest elevation, which we've talked a lot about already today, are pinyon juniper forests. This is overview of our research questions. We wanted to specifically see if the megafire impacted richness and cover. So that's richness is number of species and cover is the amount of area it takes up. And then plant growth form, those are your woody shrubs, broadleaf forbs, and the broadleaf forbs are kind of sunflowers or thistle, for a couple examples, and then our grasses. And lastly, wanted to look at the native and non-native plant species impacts. Native species are those that are historically on the landscape, and then non-native are typically brought in through dispersal from humans or animals. And we wanted to see how they were impacted across those 3 different forest types like we mentioned. This is the study site. You can see in the top corner Utah Lake, and this is down through Spanish Fork Canyon and Payson Canyon and a little up into Diamond Fork Canyon. This is a 610 kilometer megafire back in 2018, and these little shapes are depicting our forest types, and at each site they're paired transects, and this is a visual of what the different forest types look like. You can see we didn't know that the fire was happening, so these are separate sites. It's not a before and after. They're paired spatially, and we have 6 transects in each of the forest types, 6 pairs. And you can see with the aspen fir and the burn side, there's a lot of regenerating aspen, but they've been browsed pretty heavily at this site. This is a oak maple site, and this one you can also see regenerating oak. It's also got vegetative regeneration, but it's more focused around the clumps at the trunks of those trees. And this is a pinyon juniper site. With these transects, they're 50 meters long. And yeah, you can see visually it's even different just looking at the ground. So at each of these transect lines, we would put these quadrats, these Daubenmeier frames down on the ground to get an estimate of that richness and cover that we talked about. So we'd first identify the species that are in the transect and then quantify them with using ocular estimation. So we'd say that's about 40% of musk thistle for this transect. And we'd gather a bunch of data from all the different sites, and these are some of the results we found. This is specifically looking at those broadleaf forbs. There's a picture of a wildflower in case you'd rather just think flower instead of forb. But our forest types are along the x-axis on the bottom, and then we're looking at richness on the top and cover of forbs on the bottom. And this first finding shows that aspen fir forests had decreased forb richness in burned areas, while pinyon juniper forests had increased forb richness in the burned areas. In terms of cover, there was only a difference in the pinyon juniper forests, where the burned pinyon juniper forests had a lot higher percent of forb cover. This next graph has a similar setup, but we're looking only at species richness between native species on the top and non-native species on the bottom. So the significant difference here is in the aspen fir forests, and native richness decreased in those burned aspen fir forests. And if you know much about aspen, you know that they're typically a very biodiverse ecosystem, and that's why they're so beneficial. We're always trying to restore aspen habitat because they're not only good as a tree species, they're really good for the microclimates and these the soil moisture they bring that promotes other species. So richness is really important in our aspen fir forests. In terms of non-native species, there was a significant increase in non-native species richness, so the number of non-native species in pinyon juniper forests that were burned. And then this last graph shows percent cover of native versus non-native species. In this graph, there's maybe some biological differences, but nothing jumped out as significant until you look at so this is native species, but with non-native species, both oak maple and pinyon juniper had higher cover of non-native species in the burned sites. So the big takeaway from this is that megafire did impact these forest types differently in terms of their understory plant cover. With the aspen fir, we saw decreased biodiversity, especially in the forbs and the native plant species. With oak maple, we saw minimal changes, but they were negative increases. So non-native plants, they might not all have a negative impact, but there is a lot of question marks with a lot of them. And specifically in the pinyon juniper forest, we saw that increase of non-native species cover and richness. But the interesting thing with pinyon juniper is the species that rank top 10 in percent cover, 8 of those 10 species were non-native, and one of the species was cheatgrass. And you habitat people know that cheatgrass is not something you want coming into your PJ forests because it increases connectivity. So when fire comes through, the forests can burn a lot more. Pinyon juniper are water limited sites that typically have a lot more bare ground, and it's important to keep that characteristic to prevent catastrophic fires going through these forests. Switching gears a little, and if you want more details, we can obviously talk about this more after the fact, but we're going to talk about the tree regeneration now, so the saplings within each of those forests in terms of the regeneration, so their height and density, but also in terms of ungulate herbivory and how that impacts their regeneration. Again, these are the same sites, the 3 different forest types with the paired transects spread out throughout the fire. We have the 50-meter transects and then 2 meters wide, so we have belt transects, and each sapling within there we counted in terms of height and browse. And so those apical meristems, those leading growth tips, if they were chewed off, that would count as a browse. And then we just count the number of those. So first we'll look at the density results, and this is year on the x-axis with density on the y, and these are years 1, 2, and 3 after the fire. So the fire happened in 2018. This date is the summer of 2019, 2020, and 2021. These are our coniferous species, the juniper, fir, and pinyon, and the white bars represent the unburned control areas, whatever you want to call them. And you can see there's saplings, there's a higher density of saplings in the unburned, and there's almost no saplings in the burned areas. And these are our broadleaf species, so the oak, maple, and aspen. And you can see there's a little variability. Oak had very significant increases in the burned areas in terms of sapling density. Maple had the opposite trend, with only a little bit of sapling regeneration in the burned. And then aspen, there's no significant difference, but it could be biologically significant. There's a lot of factors that could play into that we could discuss later. But the main trend is that the vegetative species showed positive responses to fire, which makes sense because this is so soon after the fire that those vegetative species have the existing root system or the trunk that they can pull nutrients from to grow. And our seed regenerating species showed immediate negative responses. And that makes sense. You burn up your saplings and it's going to take the seeds a while to grow back. This is looking at the first 3 years after fire again, but in terms of the browse percent and specifically of our broadleaf species. And immediately after the fire, that within that first year, herbivory was much higher in the burned areas when compared to the unburned areas. But over time, that decreased. And so by year 2021, they're almost the same in terms of the herbivory level. And a lot of the post-fire areas have these green saplings that are visually drawing the wildlife to them, but they're also higher in nutrients, and so it makes sense to see a higher browse. But the important part is that it didn't surpass that 30% critical threshold that we talked about earlier when, as a recap, if it goes past 30%, there's negative impacts on forest regeneration. And so it may have gotten to 30% in a couple sites, but it wasn't significant enough to be maintained, and the forest regeneration wasn't negatively impacted, which we can see in this next graph, where height is continually increasing every year. And I thought there would be a cool interaction effect here because it looks like the burned species by the darker bars are growing a little bit faster, but we didn't pick that up statistically, sadly. But just to recap, after the fire, even though the forest burned and a lot of people were negatively affected by it, I grew up in Salem, Utah, so a lot of my neighbors were being evacuated during this fire, and it seemed pretty terrifying. But even though it was scary and there's a lot of herbivory, the forest is growing back well. These forests are needed, and I'm sure all of you are aware of this, that fire helps to restart the system, bring in more light and nutrients, and refresh those trees. This is shifting gears. This is just a little note on the aquatic side of things. So you can see the pictures of Utah Lake here, and I don't know if you can see it very good, but where the arrow is pointing, you can see a black cloud, and that's the sediment and everything. This is runoff directly after the megafire. So the megafire was burning, and towards the end of it, a Hurricane Rosa, the remnants of it came over, and so Ben Abbott's lab, they have a small army over there. They got a lot of manpower to put all the water monitoring sites on there right before the hurricane came. And if you scan this QR code, you can read Trevor's whole paper. It's really good. But a highlight from it is that the megafire caused a 2,000-fold increase in sediment flux and a 6,000-fold increase in particulate carbon and nitrogen flux over the course of the storm. So it wasn't that, the storm wasn't here that long, but there was, like, you could see it from space. It was such a significant impact on the watershed. And something interesting, as paper points out, is that the megafire had such a big impact on our stream chemistry, but it still is pretty small compared to human impact. And so he goes into all the details, and you really should read the paper. It's pretty good. And then the picture of the invertebrates over here, there was a student who's studying the invertebrate impact, but she didn't find any significant differences in invertebrate diversity, and it's likely due, she says, to the evolutionary exposure of these invertebrates to fire and the fact that the first year of data they were able to collect was a year after the fire. And because these are our reproductive species, they probably were able to grow back before she had the chance to sample that, any differences that would have occurred. And all of this work obviously wouldn't have happened without all this WRI funding and the many, many hours by all these students. So with that, I'll take any questions before you have a delicious lunch.
Okay, questions for Devry?
I was just wondering if any of the areas in your study was seeded post-fire.
So there was seeding that occurred, and I never was able to get polygons that are good enough, which isn't a great excuse. But I did look at the species that were seeded, and the top species didn't correlate with any of the species that were seeded. So there could have been perhaps interactions between the seeded species and the species we found, but the most abundant species weren't the ones that were seeded in our study sites.
Hey, Devery. First, a comment. This is really interesting research and very much needed, so thanks. But question, do you think or have a hunch maybe that long-term monitoring of the mega fire sites might show a difference beyond the 3 years that you've shown as far as biodiversity and cover?
I would love to have long-term data with this. I know they're continuing to do studies in the lab, but it's more focused on the tree regeneration because the identification of species takes a very specific crew and very knowledgeable manpower, I guess you could say. So I don't know that they have any plans to do that in the future. We did get a lot of help from obviously all these people, but it takes a lot of work that I don't know that we had the time or the money for at the moment. So.
Any other questions?
I think you basically answered it already, but in your Pinyon juniper sites where you saw an increase in like flowering plants and forage production, that's all attributed to probably non-natives and invasives? Right?
It was mostly non-natives, yeah. And if you want to see like the different species, we can get and talk about that later too if you want. But.
Okay, last call for questions. Okay, thanks, Devery. Okay, we are going to break for lunch, and it's an hour-long lunch, so enjoy each other's company, get to know each other, enjoy some good barbecue, and we'll get started again at 1. Folks, there's plenty of food, so feel free to hit the line a second time if you're still hungry. Okay, everybody, let's start finding our seats, and we'll get started here in a minute or so. All right, let's go ahead and get started again, everyone. Next up, we're going to hear from Michelle Jeffries from USGS. Michelle was also unable to join us in person today. We offered to pay for her travel and everything, but she's a federal employee, and I think every federal employee understands that overnight travel is a little difficult right now. So she has been gracious enough to record her presentation, and she is online for question and answer after. So let's hear from Michelle.
Hi, my name is Michelle Jeffries with the U.S. Geological Survey Forest and Rangeland Ecosystem Science Center. And today I'm going to be presenting to you an introduction to the Land Treatment Exploration Tool. Before I dig into the details, I first want to thank the Bureau of Land Management for their very long-term and ongoing support of the projects that I'm going to share with you. I also want to thank all of the very dedicated folks who have worked behind the scenes on these projects. In particular, David Pilliard has been the PI for this project, and Justin Milty originally created the infrastructure behind everything I'm going to be showing you today. And these little circles that I'm showing you are all of the different biological science technicians who have contributed to some of the work I'm going to be talking about today. I first want to start by introducing you to the Land Treatment Digital Library, which is a project that has been co-produced by the USGS and BLM to make their land treatment information more accessible since 2009. So this includes anything like seedings, prescribed fire, mastications, herbicides. Essentially any kind of vegetation or soil manipulation is documented both spatially and tabular in the Land Treatment Digital Library data structure. And so essentially how we've done this is by taking paper and digital documentation and getting that transcribed into a database that's then available to users via our website. And to date, we've been very busy, and this is showing you that we have documentation of over 25,000 projects comprising over 71,000 treatments, and the date range for that is since 1910. And the map on the left here is just showing you a count of treatments per state to show you where we have treatment information across the western United States and which states have the most number of treatments. And you can see Utah down there with over 6,000 documented treatments. And so now I want to talk about this information within the framework of adaptive management for land treatments. When the Bureau of Land Management implements treatments, they document their activities, their funding, and those sorts of details in a digital repository that's called the Vegetation Management Action Portal, or VMAP. And there's also some fuels folks that might be aware of some documentation of fuels work in this other system called Inform. And VMAP and Inform are connected. So implementation details are now being recorded in a standardized way in these data structures over here. These treatments, once they're implemented, are monitored with some kind of standardized monitoring, and for the BLM, that's called the Assessment, Inventory, and Monitoring Framework, or AIM. And over here on this archive piece, we have the Land Treatment Digital Library that I just introduced before that documents the legacy data from the Bureau of Land Management going all the way back to the early 1900s. And when we started thinking about adaptive management of land treatments, we realized that there's this gap between implementation and this very useful archive. And how do we complete this cycle of adaptive management? By using information of these past treatments to inform future restoration efforts. And that's where the land treatment exploration tool comes into play. And that's what I'm going to spend the rest of today talking about. So the land treatment exploration tool is a publicly available resource for managers to identify characteristics of their planned treatment site, to identify past treatments that might share similar characteristics to the one that they're planning. You can use it to create maps, summaries, and reports for planning purposes. And it's going to facilitate communication and integration of data across administrative boundaries. So the different types of data available on this tool include things like over 70 different spatial layers, on-the-ground monitoring data, special status species served up from the Fish and Wildlife Service, current and future drought conditions, remotely sensed vegetation cover through time, and restoration and rehabilitation investments, so looking at those past restoration actions. And here are just a few example use cases about why you might want to use the land treatment exploration tool. Post-wildfire treatment planning, fuels treatments, wildlife habitat, areas for retreatment, areas to collect seed, areas for energy development, NEPA documentation, or allotment renewals. And essentially, any time when you're looking for information about the ecological context of some area, the land treatment exploration tool is going to be helpful for you. And today, I'm going to show you a live demonstration of a post-wildfire example that also has some benefit for wildlife habitat. So the example I'm going to use today was the Cherry Creek Road wildfire in Utah. This was a human-started fire, about 700 acres, in October of last year. All right, so here we are on the publicly available website, and the tool includes 6 steps on the left, and then some main tabs going across the top, and then we're going to start on this large map area, but this view is going to change as we walk through the different sections of the tool itself. So step 1 over here on the left is where you describe what you're planning on doing on the landscape. So for this example, I'm going to use the name of the fire as the project name. So we're going to use Cherry Creek Road Wildfire Rehabilitation. And what type of treatment are we planning is next? I'm going to include ESR Wildfire Project. And perhaps I'm thinking that I want to do some seedling planting, maybe an aerial seeding, an area closure, and an herbicide spray for annual grasses. Step 2 of the tool is where we define our area of interest. So what is our planned treatment boundary? In this case, I downloaded the fire perimeter from the NIFC Open Data Portal, which is the authoritative repository for fire polygons. So I'm just going to upload that shape that I downloaded. And it is a zipped shape file, and it automatically pulls it in and zooms to this area. So just to show you where we're at here. So here's Utah Lake, Provo's over here. We're just over in here by the Sheeprock Mountains. So here's our fire polygon that we're working on. And step 3 is where we're going to start to explore the site characteristics of this fire polygon. And it's going to walk us through several pieces of the tool here. So the first part of step 3 is going to toggle us over to site history. And this is where we're going to get our first information about past BLM restoration efforts. So this top map here on the left is showing you treatment frequency. So how many treatments do we have documented in this area? And then the map on the right is showing you the types of treatments we have documented. So this area has indeed been treated in the past. It's at least had some vegetation soil manipulation, something like a chaining perhaps. And as I scroll down, I see a little notes box here and a table. And this table is showing us the past treatments that have happened. So we've got a chaining and seeding from the 50s. We've got fire rehab from the 90s. And you can see these are hyperlinked, and this is going to link us directly to the Land Treatment Digital Library, where we have that legacy documentation about these treatments. And so ahead of time, I took some notes on what I learned from the Land Treatment Digital Library, and I'm going to put these notes right in here. And so I documented, that it was a chaining and a drill seeding, and I listed what species have been seeded in that area. As I scroll down, I'm next going to get a look at the fire history in this area. So this map is showing you a map of fire frequency, and we can see that this area has almost entirely in this fire perimeter burned twice. And when I was looking into these fires with some layers on the main map, I found that this area burned twice, once in 95 and again in 1996. As I keep scrolling down, the next thing I'm going to get here is remotely sensed vegetation data through time. So for our fire polygon here, here's the average cover value modeled from satellite imagery. So we have bare ground litter, annual herbaceous, perennial herbaceous, total herbaceous, non-sagebrush shrub, sagebrush, total shrub, and tree cover. And I can hover over this and see the values through time. And this is interactive, so I can turn things on or off, and it will rescale the y-axis depending on what's turned on. So we can see that disturbance event that happened where those fires burned, and then the vegetation response after the fire. So for example, you can see that total herbaceous cover used to be around 30%, and now it's sitting more around 50%. As I keep scrolling down, I'm next going to see the average monthly precipitation and temperature for our fire polygon. So this is coming from a 30-year average. So we can see these values for each month, and this might be helpful for timing things like when you might want to seed a certain species, if that species has a threshold of water requirements to germinate and survive. The next part down here at the bottom is showing you one of the many different resources for past drought. So this is one standard indexed across a period of reference. And then here at the bottom, we link to several very useful drought resources that we suggest folks take a look at. So from these links, I was able to take some notes on drought history. And so here are the notes that I took by clicking through some of these links. And you can even take screen captures from some of these links and put them right into your report. So from the drought severity index portal, I was able to get this chart of the evaporative demand index for this polygon through time. So we can see the periods of non-drought and drought conditions based off of this specific drought index for this specific location. So that's the end of the site history tab. So I'm going to scroll back up to the top. And we're still on step 3. And the next part of step 3 is going to direct us over to the monitoring tab, which is just right here next to site history. And this is where we're going to see on-the-ground monitoring data from the Bureau of Land Management. So this is pulling in the AIM data set that I mentioned earlier. And the first part here is showing you all of those on-the-ground monitoring points that are directly within your fire polygon or treatment polygon, and then within some buffer. And by default, we have it set to 10 miles, but you can toggle this to whatever suits your needs. So you can identify these points and get all of the attributes about them. And then underneath the map, we have some tables of data that show you a few of the attributes of those data points. For example, things like live sagebrush cover or tall perennial grass cover or the grass species that were observed there. And so there are 36 of these terrestrial AIM monitoring points within 10 miles of our planned polygon. So we can use this information for pre-fire vegetation cover very near, so not within our fire polygon, but right next to it. So we can have a pretty good idea of what plants were out there, what range of cover values we expect there to have been before the fire. And if we check these boxes, it's going to add these rows of data to our report that it's generating in the background. So there's a couple different data sets in here. That first one we were looking at was the terrestrial AIM data set. We also have the landscape monitoring framework data set in here, which also collects line point based data, which can be displayed in the same way. And then we also have some waterway monitoring. So that's called the LODIC AIM data set that gives you some information about stream stability, length, flow, species, things like that. So if you're worried about waterways in the area, you also have some monitoring data about those. All right. The next part of step 3 is going to direct us over to the Fish and Wildlife Information for Planning and Consultation tool. So this is embedded right within our tool, and we're essentially tapping into this information via API. So we're not recreating the wheel. We're sending your planned polygon to their service, and their service is returning their data. So the type of information that their tool generates are endangered species. So in this area, you might have to be concerned about habitat for these species of birds and plants and insects. They will also list migratory birds of conservation concern, as well as wetlands in the area from the National Wetlands Inventory data set. And if you need the full report from IPAC for NEPA, for example, this URL that gets generated here will open up the full tool with your polygon already loaded and ready to go. All right, the next step of step 3 is to take a look at the planning map. So if I click on this, it's going to toggle me over back to that main map where we started. And it's also going to toggle me to the Layers Legends tab over here. And so this is where you can find those about 70 different data layers that you could turn on and just investigate. So, you know, there are things like allotment boundaries, ownership, ecological classifications. So maybe you're thinking about seeding a certain species, maybe you're thinking about seeding blue bunch wheatgrass. Here are the seed zones for blue bunch wheatgrass. So where might you want to collect seed to seed in this area? And that seed zone is going to be variable depending on the species you're collecting seed for. So, you know, if you're looking at sagebrush versus those grasses, you're going to be wanting to collect seed from different locations. Also in here are some GSurgo data layers. So a lot of those 70 data layers are actually nested within this categorization here. So for example, maybe you're interested in pygmy rabbits. There's some model data within GSurgo about pygmy rabbit habitat potential. And so I can turn that on and you can see the areas that have been modeled to be suitable or not for pygmy rabbits, for example. Or maybe you are interested in sage grouse. We have a grouping here specific to sage grouse, things like breeding habitat, priority areas for conservation, and things like threat-based ecostates. So there's a lot of different data layers that you can poke around at. And in the next step of the tool, we're going to summarize some of those data for you. All right, so the last part of step 3 is to take a look at your drought forecast. So this is going to generate an estimate of soil moisture conditions for the last 6 months and future 12 months. So I'm going to go ahead and click this, and we're going to come back to this page because it's going to take a couple minutes to generate. So while that's generating, I'm going to go ahead and go back over to my left side here and go to the next step. And this is where we're going to automatically generate some summaries of data for your polygon and these data layers. I'm just going to select them all and add them to our report. And so now we're on this report tab here, and we're starting to build our summary data report. So you can see all of these values have already populated. So we're getting information on this specific fire polygon and, you know, what is the resistance and resilience here? What is the sage grouse breeding probability? Fire risk, land fire cover data, heat load, ruggedness, ecological site name, all kinds of different data layers here. So this is a subset of those 70 data layers that we were able to look at. This automatically summarizes them for you so you can have an idea of the coverage of your polygon for these areas. And the nice thing about this is that everyone who uses the tool is getting the same information back. So whether you're, you know, based out of Battle Mountain, Nevada, where you don't have very many resources, you're getting the same information as someone based out of a bigger city with, you know, a big GIS shop itself. All right, so the last steps of the tool is where we're really going to dive into those past legacy land treatments documented in the Land Treatment Digital Library. And we're going to do that by searching with some distance in mind. Let's search by ecoregion. So let's find all of the past legacy land treatment digital library records that overlap with this ecoregion. You can actually see that this treatment does hit 2 different ecoregions. So it's going to find all the treatments in all this area. So I'm going to go ahead and click Query LTDL, and it's going to search for all those land treatment digital library polygons from the BLM that overlap in this area, and let's see if there's anything that we can learn about them. So that returns about 1,200 matching treatments. That's still a very big bucket of treatments to learn from. So the first filter that I'm going to add on here is find me those treatments that have something written down about how well it may or may not have done. So that took us down to 340. I'm also going to filter this down to treatments that included seedings. And why don't we include specific seeded species while we're at it? How about some sagebrush? And so that takes us down to less than 50. That's a manageable amount of information to try to sift through here. And so this little table here is telling us the name of the project, the type of the treatment, the year that those treatments happened, and then some information about the treatment. So green is better than yellow, and you can filter and sort by these different fields. So if I sort here, so here are our most recent treatments that we have documentation of. And you can see they're pretty good, lots of green in these rows of data. So let's take a look at some further details. So here's rotor wing aerial seeding. Let's see what we can learn from it. So we can see that this was done by the Salt Lake Field Office in 2017, and their goal was to have 30% composition of the total plant community after the 5th growing season. And then we have some information on about what they did and some results about how well it did. And so this is typically a summary of that on-the-ground monitoring data. So you can read through this and understand, is this the type of result that I'm hoping to emulate in my current treatment? Or maybe this past treatment didn't work at all, and we want to use it as justification to not do it in that same way. Maybe a drill seeding instead of aerial, or maybe a different time of year, or different seeded species. But it seems like this treatment actually did work pretty well. And here's the seed list that they used. So they used forage kochia as well as big sagebrush. And then you can also see that same sort of vegetation data through time that we showed in the site history tab. So for this aerial seeding, here's its vegetation through time. And we're also showing water year precipitation for context, as well as years of fire. So when did this legacy treatment burn? And when was this legacy treatment treated? And were there other treatments? So this particular aerial seeding happened in 2017. There were also some other treatments implemented in that same year. And so you can get an idea of the vegetation cover through time with a little bit of context with the water year precipitation and disturbances. So let's say I want to emulate this type of treatment maybe. When I check this box, it's going to add it to my report. So it's adding it right to the bottom of my report as a reference, as a past treatment for something useful for me to learn from. Okay, so before we poke at that report, I want to quickly switch back over to the drought forecast. It should be done calculating, and it looks like it is. So this is called the Seasonal Ecological Drought Forecast. And essentially what this returns is information on soil moisture, air temperature, and precipitation from the past 6 months and future 12 months. And so we're going to have an expanded section for each one of those pieces of data. So here's soil moisture. So how accessible is the water in the soil? And we can see here on these graphs the typical conditions for this location in black with these shaded gray regions of variability. And then the yellow is the modeled observed data. And then here's the today line and the future projection of what it might look like in the next year. So we can see in the past 6 months we've had some periods of dry soil and moist soil, but within the range of variability for this site. And looking forward from today, it's going to remain a little bit dry in the soil and then be pretty average moving forward, but it looks like a period of dry next winter. And you can change this information for different soil depths as well. So by default, it is showing you the top 15 centimeters of soil. So that's going to be really important for seeds and seedlings. But you can also change that to 15 to 50 centimeters, as well as to greater than 50 centimeters. And you can see some of that soil moisture never made it down to those deep soil layers in this area in the last 6 months. Okay, so the next section is air temperature. So the same sort of graph, but now with air temperature, and you can see this area was abnormally warm in the wintertime and is predicted to remain warm. For precipitation, we can see this might look similar to soil moisture because it is related to soil moisture. We can see a period of above typical moisture here in the springtime, and it's predicted to be a bit wet, it looks like, this summer. And then the bottom of this page shows you some metrics of potential sagebrush seeding success. So this part takes some models from recent literature and it implements their models with the situation at this specific fire. So when these data are modeled and generated, it also generates variables to fulfill these models, and it applies that data to this location. And so what we can see based off of this study from Schreiber et al. From 2018, based on their model of sagebrush establishment post-fire, looking at this location, 2025 was below typical conditions for sagebrush germination and establishment. And then this is the variability of sagebrush establishment at this location. So, 2012 looks like it was actually a pretty good year in this location. And then the predictions for 2025 are more similar to like 2011, 2016 conditions. And then over here, it will show a forecast establishment for 2026. Once we have at least 6 months of data, so it'll be in June, we'll be able to predict out into 2026 as well. And so we have a couple other metrics down here that I'm not going to spend time on today, but similar sort of idea, taking data from these prior research articles and applying it to this location to look at sagebrush establishment. And we do have some very smart folks working on modeling some additional species beyond sagebrush right now, so looking at some perennial grasses and forbs as well. All right, so I'm going to switch back over to my presentation to wrap us up to show you what that report is going to look like. It's going to give you this nice PDF report, and the example in this presentation is for a different fire example, but you'll get the point here. So you got a nice title page with the name of your project, the treatments that you're planning on doing, and then it's going to go through and include your notes that you took on each section, and it's going to show each section of data. So those summary sections like seed zones, land fire vegetation cover, ecological site name, things like that. And then at the end, you're going to have those treatments that you included from steps 5 and 6, where we were looking into the land treatment digital library for past treatments. And so this was a lot of information, and I know it was a lot of information, but don't worry, we have a ton of resources to help you use the tool. So we have a full user guide. So we were on the start planning page of the tool. On the user guide part of the tool, there's a full step-by-step breakdown. If you like reading through user guides, this link is for you. We also have a nice landing page that has lots of tabs across the top. And in that landing page, we've got great information like news. So whenever we have new updates to share, we will link a news item in here for you to see. And then if you're using the tool and instead of using the user guide, maybe you like watching tutorial videos. We've created several tutorial videos to help walk you through these different steps. And if you need additional help beyond this, or you just have questions, comments, concerns, anything, feel free to shoot them to this email right here, ltdlproject@usgs.gov. So I'm going to leave this slide up here for the questions and answer session. Here's my email, David Pilliot's email, and the project email here. This QR code is going to take you to the landing page of the land treatment exploration tool, and this one is going to take you to a case study write-up that was done using a wildfire example in Idaho. Thank you for letting me talk about the land treatment exploration tool today, and we're going to go ahead and pause for some questions.
Okay, Michelle is online, so if there's questions for her.
Yes, I had a question for one of my colleagues who is also online. Is this tool applicable to all land management types or just BLM? And she wants to know if the Forest Service AIM point data was incorporated into the tool as well.
Hi, can you hear me okay?
Yes. We can hear you.
Okay, great. So the website itself is public, and I would say that the development of the tool has been driven by Bureau of Land Management information, but that their hard work getting these treatments documented is useful for anybody. So if you're, private landowner wanting to do restoration, you can learn what the BLM has done. If you're, Forest Service employee wanting to learn about restoration and what things have worked in different areas, it's useful to you to know this legacy landscape of treatments directly from the BLM. And so I would say that it's most useful for the types of treatments that the BLM works on. So a lot of rangeland type work is their focus, and post wildfire is certainly the majority of what the BLM does. They do have a lot of timber treatments, especially in Oregon. So there's some types of that information to pull out as well. If you're, working on, Forest Service timber type work. And then for the second part of that question, the U.S. Forest Service FIA data, I think is what you're referring to, is kind of difficult to share. And so we haven't been able to incorporate any Forest Service monitoring data. However, the landscape monitoring framework data set, it was that second one, that one does include data from other groups, like the USDA, for example, their on-the-ground monitoring data is in that data set.
Okay, thank you. Any other questions for Michelle? Maeve.
I can project.
No, you got to, because she can't hear you.
I was just wondering if you knew offhand if the API for IPAC was open to anyone, or was it just a benefit of being a sister agency?
That is a fully public open API, and I'd be happy to help set you up with that if you want to reach out via email.
Okay, got another.
On your data library, are you only using federally available data sources, or are you looking at other state curated data sources?
That's a great question. So in Utah in particular, the Utah Watershed Restoration Initiative is a great source of data. When we're entering data in Utah, we do use your hard work getting the data in that format as well, but we do focus on the BLM treatments because that is where our funding comes from. So I know some state data sets will include other agencies, whereas we're focusing on the BLM, and that is, again, because that's just where the funding comes from.
Okay, Robbie.
So is it possible to get funding from other sources for the future?
Yes, yes it is. We have been talking with some Forest Service folks recently about that possibility. We also do have some Department of Defense installation data as well, where we've had agreements with some of those locations. So it's certainly a possibility. There's been interest in different conversations throughout time, and it all just comes down to getting those agreements in place and move forward from there.
Okay. Well, thanks, Michelle. We appreciated it.
Thanks for having me on. I appreciate it. I wish I was there with you in person.
Okay. Yeah, let's give her a hand. Okay, next up, we're going to hear about the Wildlife Habitat Analysis Tool, which Maeve just got here, and she doesn't know that this has already been a topic of conversation, so looking forward to this.
I'm glad to hear that. Good afternoon. I'm with the Division of Wildlife Resources. I'm with our Data Services and Geospatial team and our Heritage program. Let's see if I can figure out this pointer. All right. So I do have our URL here and a QR code, but I'll bring that up again at the end, so no rush on that. All right. The main purpose of this tool is just to provide wildlife information in your project area. We do like to provide a lot of context for you as well, but at its core, we're really just letting you know what species have been observed in your project area. There are quite a few things that you can do with this tool in relation to WRI. I think the most useful thing is probably for exploration. The whole idea is that you do not have to be a GIS analyst. We give you a basic map interface, and we don't have 70 geospatial data layers, but we do have quite a few. And I'm happy to hear if anybody wants any more added. That's very simple for us. There are two components to this tool. We have, like I mentioned, the map exploration aspect, and then we also have a report that gets kicked out that you can attach to your WRI project as kind of evidence or further data for your proposal. We're going to walk through statically, and then I'll have a video for you since it's after lunch. So to get started, you just put some basic information in, your project name, your type, and WRI is an option now, as of this week. And then you hit Create Project, and you're taken to the map view. So we have some basic features. You can zoom in and out. We have a tutorial, we have a layer list, and we have different base maps in case you don't want the imagery default. You can upload your own layers, so I think this adds a lot of flexibility. If you're doing a vegetation treatment, you can actually upload your own data. And then we do have quite a few layers, and I'll get into those in a minute. A really important button is the feedback button. I love to hear from people. I do respond if you include your contact information, and then I'll take us on. Okay, so I wanted to dig into the data to this group in particular because there's quite a lot here. In addition to wildlife information, we do have DWR data, but we've pulled in a lot of public data from partners, some of which I actually saw in the last tool. So I start with the user uploaded data because that gives you a lot of flexibility. We include information on grazing allotments, conservation districts. For our aquatics program, we do have data from our barrier analysis information tool. We include boundaries, so if you want to overlay WMAs in here, you can do that. We have the new Sentinel landscape area. We have PLSS for parcel nerds. We have energy, environmental quality, so the Sergio NRCS soils. And then we have habitat layers for 26 species, most of which are big game. And then we have hydrography, we have contours, land ownership, migration corridors, noxious weeds, key habitats from our wildlife action plan, and we include points of diversion in case you're looking at water in Utah. All right, so this is your project list. Oh, this is supposed to be a video. All right, great. Thank you. So here's where everything I just explained, you're just creating your new project. We're selecting WRI for our project type. I did a test area here in Richfield. And I left this in here, you'll see, okay, it's pretty fast. These are actual real-time timings. So you can do a search, you can put in a city, lat long, you can draw your own area, you can measure, you can upload your shape files, you can generate your report, there's that feedback button, you can change your base maps. We do have a tutorial and guides for shape files. It's very similar to WRI, so Allison has put together a great resource, so we link to that. And here's where you can pick your different reference data. It's easiest to just draw a box because you can run into issues with uploading shape files. It only accepts very simple polygons. It will lose its mind if you don't dissolve it, and it's a multi-part. But again, we have resources for that. So the idea here is if your original project area intersects with a high-use migration corridor for mule deer, you can actually see in the map interface and maybe move your project if you have that flexibility. So this is real time, and I ran this a few times the morning that I put together these slides, and sometimes it's very fast, and other times it's slower like this, and it was the same project area, so I think this is just a latent connections to our back end. So don't be alarmed if you get a little spinning. Just don't close the tab. You can move on to another one, but if you close the tab, you actually have to restart your query. So as you can see, it can take 10 seconds, and the more data you're entering, the longer it will take. So this is the end of the video. All right, so now I'm going to move into the report component. This is also kicked out as a PDF. It goes to your email, but you can also access it in the project list. And here's kind of a static version. This is the actual PDF. So you can see here the beginning of the table list. So we have the species name. We do it within a half-mile radius and a 1 mile because we want to protect the location of the species. We don't give precise dots on the map. but this will let you know what is very likely to be in your project area, or at least was observed at one time. So we have our species here. If you click on that link, it will take you to our field guide if you want more information on the species. This example does not have a distribution model, but if it did, there'd be a thumbnail, and you can see it would pop up in another tab. And so here we've got the Pinyon Jay. We include the scientific name, our wildlife action plan status, whether it's a species of greatest conservation need or species of greatest information need. We do include the ESA status. We recognize we don't have authority, but we do try to keep up with that. So we include that because it's of interest to a lot of people. This last report date. So some of our species, we have data back to like 1913, and that may be the last time because we pull this data from a lot of sources, which includes museum records. So if you see 1913, it means it was from a museum record. It doesn't mean that the species is not there. It just means that maybe we didn't survey in that area. Conversely, we may have revisited that site 20 times. You're only gonna see the last reported instance, the most current. So there's not a lot of context to that data. It's really just a snapshot of the last time in your project area too. It may not be consistent across the state because it's literally looking at what's on the ground in your project area. Okay, so within our report, we also include mitigation strategies. These come from our impact analysis biologists. And this is kind of to help people. We recognize you can't always move your project, but maybe you can adjust the timing of it. So that's where this comes into play. And we're also kind of highlighting suggestions for least impact to the species from your project. Oops. We do include a contact because we really hope that this tool kind of spurs people to reach out to us. We can only present so much information in this format, so please reach out to our impact analysis biologists. They have a lot of knowledge in their region. And then this is just kind of referring to those layers that you were able to select in the map. The way the technology works is that it takes a screen capture. So if you have not selected these layers on your map view and displayed them, you won't get the image. You'll still get these tables and the data, but if you want to include that image, make sure to have those checked before you generate your report. Okay, and then the data. This is the part that I'm most excited about. There's a lot that goes into this. We've migrated quite a few different databases. While it is based on occurrence data, we're hoping to build out our distribution modeling because occurrence data is only so good. So we're really hoping partners will be excited about this and share their data. That's why I was asking about the API. I really want to pull in IPAC data. And then I've already mentioned the tool quirks, but it's worth mentioning again. I get quite a few emails every week about shapefiles that don't work. The way the tool currently operates, if you upload bad geometry, it will just spin and spin, and you can't tell what's going wrong. It's almost always an overly complex polygon. So if you stick to the same type of shapefile that you would use for WRI, you'll be set. It also can take a while. It can take a half an hour to generate if you have a couple 1,000-acre project and lots of data. So suggest just opening another tab and moving on with your life while it generates. All right, and here we go. We've got our landing page and a URL. And I realized I skipped by a really important thing I wanted to highlight with the map analysis. Some examples of the way that you could use the data are, say you're looking to benefit mule deer. You can pull up critical habitat, you can overlay that with land ownership and understand where you can make an impact for mule deer. For Pinyon Jay, if you have a certain occurrence data, you could upload that and you could see that 85% of mule deer Pinyon Jay habitat is on BLM land. So that's an important clue to reach out to BLM for partnering on WRI. All right, that's it. Thank you. Any questions?
Questions for Maeve? Got plenty of time for questions. How many people are already using this tool just by raise of hands?
Yay, that's good to see.
Hi, Maeve. I have a two-part question. My first question is, the report that you generated and the species that it spit out, is that reflective of those 26 wildlife species that you have habitat data on?
No, so actually it pulls any occurrence data for any species, including plants, big game. Our old tool was just our species of greatest conservation need, just heritage data. So anything that DWR knows about and is in our database is pulled for that table. However, the reference layers, that would be the 26 habitats, and that'll kind of show up as polygons on the map.
Gotcha. So just to double verify, you are pulling the historic natural heritage program data?
Yes. And I will say we have seen some changes from the old tool and the new tool, and that's because we're handling the data differently. If there was not a last reported date, we're not including it because we don't know what that means. So we're making an effort to clean our data as we're presenting here, which is really a great outcome of this tool. When it was first released, I got some really angry emails, but I was happy because it meant that people were able to see the data and interact with it and correct it. If data is hidden away, we can't make it better. So.
Is there a limit on the size of the polygons that can be put in the tool as far as running reports?
So you could we thought about this from a data protection standpoint. You could technically encircle the entire state, and it would give you probably, I haven't done it, a 10,000 page report, and it would list every species known to the DWR in the state of Utah. I think the complication is more just the patience of the users for a large polygon. And then it is a lot of data to wade through. I would love it if we could filter out like the species of greatest conservation need, or maybe even the federally listed species, but we don't have that capability currently. So it's really just kind of what you want to deal with. We didn't limit any of the data.
Maeve, so along those lines, what are some of the future plans for the tool, and what additional data could show up there?
So currently we're limited to vector data. I'd love to include slope and precipitation. Raster data is just much more complex to deal with. I'd love to incorporate heat maps from our wildlife tracker data. We have much more information in the database than we can present through the tool because of that kind of complexity. I'd love to include more on tribal lands are a little tricky with the definition in terms of culturally significant species. And then I'd also like to include some cultural resources. I know that comes up a lot in WRI, having to do those archaeological studies, but we could at least give you kind of a broad brush for public data.
Any other questions for Maeve?
Oh, I'd also like an error button when you upload bad geometry. That's on the list big time.
I'm just curious, is that same geometry issue what we have to deal with in our system? So, yeah.
Yeah,
I think so. It's
this group should be trained on that, right?
Yeah, you have to dissolve your shapefile and zip it before you can upload it.
Yeah, and I'll say to that point, it's already buffering the data by a half-mile radius. So if you have a really complex border, just make it a square. Like, it's not going to change your data too much.
So maybe tell us about the Wildlife Action Plan data that's in the system now. Is it the updated 2025 information? That question was asked earlier.
Oh, sure. Yes, actually it is. It is only the 2025 data. We thought about including both, but we decided that would be confusing. So you'll see species that are species of greatest information need. That's new in this Wildlife Action Plan. You'll see plants. So yeah, we're pretty excited about that. I'd like to incorporate some threat data from our Wildlife Action Plan in here too, eventually.
Okay, Robbie?
I guess because it's buffered, it doesn't share the exact locations, like the point data. Is that right?
Yes, that's why we elected to go with the tabular format, because legally we're allowed to provide, it's not considered a location, even though it is spatial data. So that's kind of how we walk that line between protecting the species, but also trying to help the species.
I guess I'm just having one thought that maybe because you have that big buffer when you're doing this for projects, maybe make your square really small. So, because you don't want to get species that really aren't in your area of treatment. So.
Yeah, that's true. And another point kind of in that same vein is that just because we saw a mule deer in a neighborhood doesn't mean that's great mule deer habitat. So that's where the reference data comes in, and where the distribution modeling, which is really where we're hoping to move for all species, because seeing a species in 1913 isn't helpful to anyone. So.
I think that's why you put the sensitive species contact information right on there too, isn't it?
Yes.
Okay, any last questions for Maeve? Okay, thank you, Maeve.
Yeah. Thank you all.
Okay, next up we've asked Kevin Gunnell from GBRC to come and give us a presentation on the long-term monitoring of WRI projects. The southern region kind of saw a subset of this, and we thought it was interesting enough that we'd do it for the whole state and ask Kevin to give it. So, Kevin.
All right. Just make, which one's our laser pointer? Oh, nope, that's turn off. The palm. Oh, okay. Gotcha. All right, Kevin Gunnell from the GBRC. For those of you who don't know me, oversee the seed warehouse as well as a couple of our projects, the range trend monitoring and research projects based out of the GBRC. Today, like Tyler said, we're going to go over really just a road trip of WRI treatments throughout the year. This will be a bit of a repeat for those who were at the southern region, but we've tried to expand this to more of a statewide perspective on things. So just jumping in for an overview of the range trend program. Long-term monitoring project set up around big game, primarily winter range habitat. It was really what this project was for. We're federally funded through PR dollars as well as BLM and Forest Service money. Our project has 3 full-time biologists. Jason Cox down in the lower right should be here, but he's out on the lower book cliffs in the lovely Nash Wash for all of you guys who have been out there. So I don't know who got the better end of the deal this week, but yeah, they're really exceptional crew, plant ID, any of that. If you need plant identification or monitoring, that's a great team to look to. Some history. This dates back a long ways to the 50s with the range inventory project. Those were non-permanent transects going throughout the state. In the 80s, an interagency committee got together and developed some standardized protocols. Those protocols have changed somewhat throughout the years, but they're permanently placed long-term. And then with the inception, well, even pre-WRI, early pre-WRI in 2004, we started monitoring these restoration projects throughout the state. Just to give kind of a brief cycle of how this works. So again, we monitor both just habitat without treatment as well as habitat restoration. It happens that a lot of our regular monitoring have been treated just because WRI is big. But we monitor that regular rotation on a 5-year basis. And then our habitat restoration is typically on a 3 to 5 year rotation. And we try to get pre-treatment data for anything we do. We don't have, unfortunately, control comparisons, but we try to use that pre-treatment for reference in our assessments. Where these occur, just land ownership wise, so the outer ring there is the regular range trend monitoring, inner one is WRI, and you can see it's split in our regular monitoring, mostly through BLM, Forest Service, state lands and private lands, a little bit more heavily to BLM and state lands on the WRI monitoring. Objectives, again, it's really big game oriented, and so just note that I do work for the Division of Wildlife. This monitoring is going to have in my suggestions and things from these, it's going to be wildlife based, but really want to look at long-term changes, the impacts for management decisions, and evaluate effectiveness of the habitat improvement and do adaptive management along the way. If you're not familiar with it, please, I don't have a QR code, but it's really easy to find our data. Just Google Range Trend Utah, it'll come up. It's a really rich, interactive site. I mean, as far as all the photos and any of the data, everything I'm going to show you today is accessible through this. So if you have not used this, please do use this resource. It's a really good resource. So with that, we're going to step into the tour of just restoration and the monitoring that's gone on throughout the years. So just know that we monitor a lot. We monitor a lot of different types of projects, but I'm going to really focus on these main ones. And this happens to be largely tree reduction treatments, but we will get into the harrow and fire world as well. And I am going to differentiate and maybe harp on some of the seeding because I'm a seed guy, sorry. So getting into lop and scatter treatments. I promise I'm not going to show you too much data, but this is a data-driven project. And so I'm going to show, these graphs are fairly standard. And I just want to point out a couple things. You don't even really need to look at these graphs. I'm going to bullet point a couple of things to point out, but just to walk you through them. These numbers along here, because we have that offset rotation, they're not similar years, so we bucketed them into categories of pre-treatment 0, 0 to 3 years, 4 to 8, and so forth, up to 18 years out on those. As you look, and then the end value, right there is the number of studies. Obviously, more recent has more. Older treatments, we have fewer long-term, but we aren't looking at exactly the same bucket, but overall, we think they're comparable to look at. On the woody cover, just know preferred shrubs bottom, other shrubs, trees top. On herbaceous, we're looking at perennial grass, perennial forb, annual grass, annual forb. That's all you need to know looking at those. So just lop and scatter. Not a lot to tell you for this long-term data. And the other thing I want to say about that end number there, this is really high level. Like this is every study that we have that's a lop and scatter just thrown in there. We have not selected at all for this, so this is everything across the state. If you get more parsed out, you can get more nuanced information, but this is just generally. So really for lop and scatter treatments, we all know it's more of a preservation maintenance method. There's not a huge flux or changes in cover, but we do see benefit by putting these in. So now we start the road trip. And I will try not to go way too long on this, but I'm not kidding. I could go for 4 hours of showing you photos of these, and I don't want to be that uncle from the road trip, that goes that long, but they're pretty fun to look at. And this is almost a celebration of you guys and your work. It's pretty cool stuff. And I know we also get beat up sometimes, like, where's the bad examples? And there are bad examples, and I'll maybe show 1 or 2 of those. But all in all, you saw that data back there. Like, overarching, when we put everything together, these are what we're seeing across the landscape. So this Sulphurdale project is southern region. The elevation was 6,300 feet. Obviously pretty encroached here in 2005. The trees got treated, I think it was that fall of 2005. I'm sorry, my notes aren't up here. So, but obviously the trees go away. Sagebrush, bitter brush is responding on this site nicely as we work through the years. 2021, I think there's one more year. Yeah, 2023, you can see that bitter brush, pretty healthy there. in that photo. And so as we get into the breakdown of data, and again, this table is going to be pretty ubiquitous as I go through. I'm going to have annual grass, perennial grass separated there, and then through these tree reductions, we'll look at preferred shrub and the tree reduction. But as we walk through time, our perennial grasses do increase moderately, and our shrubs have increased quite a bit by removing that. A really good response from bitterbrush on this site. Another one, just Chokecherry Springs up in northern Utah. I'm going to just focus a little bit here on pre-treatment and how important that is. As you look at those, there's actually 2 years of pre-treatment data up there, that 2011 and 2016, and you can see that annual grass really exploded in 2016. We had nearly 20% cover, but then it disappeared after that treatment. But we know it's a threat on this site, and so this would be one that it's got a very good forb community there as well. So this would be one that we could consider some maybe herbicide treatments to preserve and release some of those native forb species. Okay, we're moving off of lop and scatters. No offense, kind of boring. We know what we're going to get from those. So we're going to get into some other tree reduction treatments. Mastication. So if you look at that map up there, there's red and black dots. I believe the black is seeded and the red is unseeded, or it might be vice versa. Doesn't matter on this map. But know that we seed and we don't seed some of them. This one's done, in varying phases. We go from phase 1 encroachment up to phase 3, and your response really does matter based on what level of encroachment you had there. But we are seeing that browse cover continue to increase in these treatments, especially at those higher, more depleted sites in phase 3, even out 20 years. So we're still seeing shrubs come back onto this, as well as some good herbaceous responses within these community. So anemone PJ reduction. I can't go back, but so this one, I guess this is where I want to hit up on some of the seed mix components of this. And talk about being a little creative in how you do this and not thinking standard. So this seed mix that went on to this treatment was very limited in grasses and it was very forb focused. It had almost no grasses in the seed mix, and you're going to see that in this next photo. So yes, sunflower was in that mix. Go figure. The trees went away and sunflower was in that mix. But then it went away, which we expect. It was an early cereal species. It was in there, and we expected to be sort of a cover crop to help nurture in. But you see the grasses are coming back on that site. We're seeing good response from the shrubs as we come through time here. And as you look at this, there's a huge response in our grasses, but we didn't seed those. That's just the native species coming back. Again, my notes aren't on there. I think I had some notes about the amount of forbs, but I do think that they were higher on this side as well. Another one that's kind of an innovative one. This is actually pre-WRI, but what they did on this location was, it's a mastication project, but they actually drill seeded this as well. And in their drill, on the outside boxes, they put their bitter brush, and they put it on the outside boxes, and you're going to see some interesting results from that. So obviously there's trees, and then the trees are gone, and it's a really nice grassland that's come in. This is a good, fairly native site. But now as you look, you're starting to see some rows of shrubs come in. That happens to be that bitter brush is working its way into this site. And as we go through time, if it advances, you can see those rows growing up and the sagebrush infilling, as well as the bitter brush. It's a little hard to see from there, but if you look at the aerial imagery, this is just a Google Earth photo that I pulled off on the truck on the way here. 2004, you see that treatment, but then our sites right there, those are actually the drill rows of bitter brush all through that treatment area. So pretty remarkable establishment of that species on there, and it shows in the data. The one thing I'll point out here is annual grass is still quite high on this site. And so this would, again, be maybe a candidate where we've got a good understory and a candidate for, you know, some cheatgrass control as we get some new tools coming online with that. Okay, now we go into some more of the road trip, and going to be a little quicker here. But this is central Utah. This is on private ground, and this area was seeded and bullhogged in 2004. What I'll say is there was a lot of crested wheatgrass dumped on this. This was like 3.5, 4 pounds. Again, private ground. What grass you're actually, oh, yeah, can I go back? There we can, cool. What grass we're actually seeing here is almost exclusively blue bunch / Snake River wheatgrass that was seeded on that site. So the crested actually didn't establish, which is surprising in this one. There is a little bit of crested, but not too much. And we're seeing a good shrub response. So this next one, James Ranch, this is just over the mountain, the other side of the mountain, slightly lower elevation, but there was no seed put on this one. Obviously, there was a better understory here as well on this one, but the grass response was quite good on this, and again, mostly blue bunch wheatgrass in this area. Okay, and then just to give us the statewide, we're moving out to the Book Cliffs out in Northeast region. Really, this is a higher precip one. This one, again, no seeding on it because it's higher precip. And this one, again, I wish I had my notes here, but again, the forb response was quite good on this one. It's almost all native grasses, and the forb response was quite good on this community. So bravo, guys. Wide Canyon, just last example of the bullhog, because I can show it. This one, so this one had an old chaining treatment back from the 60s or 70s. This didn't have any seeding treatment on it. But that 38% cover in 2021 of perennial grasses is almost all bulbous bluegrass, and I want to say it's intermediate wheatgrass on this. There's very few native grasses on this, but we still saw a good response from our shrubs on this community. So some legacy effects from old treatments still stand, and that's going to be a theme that I hound you guys with a little bit through some of this. Moving into chaining treatments. So again, sorry I'm focusing so much. I realized I probably should have done some more novel treatments throughout this, but we've done a lot. This was long-term, and the long-term stuff was tree reduction. We did a lot of tree reduction early. So one thing to just kind of highlight in this is that the response of shrubs, you look at that top one, the shrub response is slow on these. This is almost always, these treatments are always done in older, older encroached sites, more depleted understory. And so that response is still coming in slow and not nearly, we aren't getting to the levels that we see in of cover that we see in shrub of bullhogs and others. The one interesting thing I'd point out is that we do see a flush of annual species, both grasses and forbs, in that early pre-treatment on that bottom graph, but that really fades through time. Granted, our end number changes, but that we feel like even when we select the same sites, we see that signal that we'll see a flush, and then that decrease will happen in those annual species through time. So that's a positive trend in those. Getting into some actual examples. So this is the bowler chaining out in, excuse me, out in, I believe this is out in Hamlin Valley, yeah. And well, we'll just walk into it. So private ground out here. This chaining happened in, I believe, 2004 or 5. There was a secondary treatment that we're not totally sure. Again, this is private ground. We think they were harvesting some fence posts out there, but they took out the remainder of the trees. But you can see, again, the grasses are really coming in on this site. The one thing I'd mention about this is that this is most of that grass, that perennial grass, is crested wheatgrass. We seeded that, and it did come in. There is good native establishment, but a good proportion. I think about half of this is crested wheatgrass. However, we've seen a really substantial increase in our preferred shrubs, primarily sagebrush on this site. getting into some other examples, so I got a lot of chaining examples. So from the early ones, this Glenwood chaining, again, oh man, I wish I had my notes. Sorry, I had depended on that. Good native establishment again. Oh, this is what I wanted to point out. In 2011, that's what this one I'm showing here is. We had a real flush of cheatgrass in oh, no, this isn't the one. Sorry, there is a flush of cheatgrass here. And this is that initial increase, but it does decrease as we move through time on this site, and those perennials get established within this community. And so you can see that, again, that this is the thing about chainings is they are highly depleted. So that perennial grasses, our perennial forbs, they start low, and we do get a very good increase. Usually our perennial forbs start to fade out after a few years, but the perennial grasses maintain longer term. Moving through the state, Dairy Fork, a little higher elevation. What I'd say about this one is this isn't a failure by any means, but this one has more challenges, that with musk thistle, white top, other things coming into this. This is actually on division-owned property up there. We did again put in crested wheatgrass, and I want to say about 4 to 5% of that perennial grass cover is crested wheatgrass, and the others is native species. So again, we've got a mixture of really good native species, but we do maintain some of that crested wheatgrass in there. This is probably this is again a pre-WRI, but the Santa Quin chaining up in Northeast region. This one, so this was an acquisition, I believe, in an old ranch. So there's a lot of land treatment prior to us coming into this. And as we see that response, again, really good response to that preferred shrub. A lot of that understory is crested wheatgrass, though. So just know that they stay around when you do that, when you put in crested. Helper benches, again, just to give everyone the Southeast region their shout out of activity. Again, really good responses when we come in and we're able to remove those trees that have encroached into sagebrush habitat. Okay, I think that was my last one. Okay, we're gonna get out of the trees. Enough trees going away. I know we all love seeing trees and stuff, but we're gonna step into harrow treatments. So this is often used actually as a shrub rejuvenation technique. It happens throughout the state. These harrow treatments include both the old Dixie/pipe harrows as well as the newer chain harrows, which are used more often. Probably more so the Dixie harrows than the pipe harrows or the chain harrow that you were seeing there. So something to talk about here is probably the longevity of these treatments. They are used to open holes in sagebrush, rejuvenate some of that herbaceous. We're probably seeing longevity of 20-ish years on a lot of these treatments as far as shrub reduction. A threat within these, especially at lower elevations, is those annual weedy species. They don't reduce a lot of times within these treatments. So just a couple examples of these. This Buckskin Valley in southern Utah, a pretty dense stand of sagebrush. It obviously went through with that harrow and knocked down the sagebrush in the seedings, and we had a good response from our grass species. The one thing I will say, this was an entirely native seed. This was the one that was an entirely native seed mix. There was an old chaining, or I'm not sure if it was a chaining or a disc on this one because I don't have my notes, but it was seeded with crested wheatgrass back in, I believe, the 70s. And you can see that understory there. That 27%, there's really not native species on this site. It is almost all crested wheatgrass. Our seeding didn't take crested wheatgrass maintained on this site, even though we seeded native species. So again, it's that knowledge of maybe what's there and what you're capable of putting back into those locations. All right, Badger Hall, and then we'll do the whirlwind tour of the rest of these before we get into some other fun stuff. So again, just we see we see the reduction in the preferred shrub there. Oh, and I want to point out, I forgot, I shifted from looking at preferred, or took trees out, and we're now looking at annual and preferred forb cover. So we've seen a reduction somewhat in our forb communities here, but we did see that reduction also in the shrub community. Should have some demographic information, but the sagebrush is still there. It's just changing its demographic somewhat. The Brush Creek Dixie, again, this one, sorry, where were we at here? Northeast. There's a lot of sites. I lose track of where I'm at through these. Like I say, I could be the road trip all day, but this is a lower potential. I want to point that out. This is about as harsh of an area as we work in. This 10-inch precip zone. It's dry, right, Tori, out there. So we came in, and fortunately we didn't see, unfortunately, we did see perennial grasses come in, but unfortunately we're still maintaining a lot of perennial grass. This is one site that most of this is crested. It probably was the one thing that would grow there. So I can't argue with that one. Preferred shrub is back to where it was, though. Wildcat Dixie is an interesting one in the southeast region. This kind of takes us, this one's visually an interesting one. This is a little higher elevation. This was done explicitly for sage grouse, to open up sagebrush for sage grouse. And so I'm going to have two sets of photos here. So this one goes from 2008 to 2013. And you can see that reduction in the sagebrush on that bottom row of the tables. It is still there. But as we move into the later years, so again, 2008 is our pre-treatment. Now we're working in 2017 and 2022. You're seeing that now we're approaching back to the same cover as our pre-treatment on that. So again, we're seeing, that 15, 20 years, maybe 25 years before some of these moderate elevation sites return back to that shrub cover within these communities. The one thing I will say, though, 2022, so we do pellet counts, and 2022 was our highest count of sage grouse that we had on this. So it's increased from about 8 pellet groups per acre to, I want to say, about 42 or 43 pellet groups per acre in 2022. So we are, at least our monitoring data is detecting more through time there. Okay, so going to step into this really quickly because I feel like I'm going to drown you guys here if I don't wrap up too quickly. But some interesting stuff in the fire-seeded world. Again, we know, so this is looking at a lot of our treatments that burned either through wildfire or prescribed fire and were seeded after. And obviously our shrubs are basically removed whenever fire occurs. But we are seeing shrubs come back, preferred shrubs primarily in that. It's slow, but it's steady. And within 20 years, we start to see those shrubs move back into these communities. The annual species are definitely a threat within these communities still as we work within these. So just keep that in mind as you're planning these. So just some good examples here of Greenville, double up hollow on the Greenville bench area again. Okay, and so this is again where I'm going to hound seed mixes a little bit. There was 2003. There was intermediate wheatgrass put into this seed mix, and you can see in 2013 we actually had a 12% cover of forbs. That was largely due to alfalfa that was put into the mix. That tails off in 2023. But the grass there is almost entirely intermediate wheatgrass that's come in there. And so I think we're probably hindering reestablishment of shrubs on this site with that species on this site. This is another example of that, just hounding this. This is looking a little further back in time on this site. Let me go back, sorry. So this is on the west side of the Stansbury Mountains. It's a moderate elevation, but it was treated and chained back in the 60s or 70s. Maybe it's the early 80s, they put some, no, it was the 60s. And it was seeded with crested wheatgrass. And you can see by 2007, crested wheatgrass is there, but it burned in 2008, 2007. and it's now a crested wheatgrass grassland, and no sign of shrubs reestablishing on that site. We didn't do that per se, that was an existing legacy. However, if you look up the road, this is literally a half-mile away. In fact, you can see that's the one we just looked at down the road. This is the one we're gonna look at here on this below Chokecherry Springs. This had the same treatment of that early chaining, but the seeding didn't take, probably shallower soils. But that 34% cover in 2021 is almost all bulbous bluegrass. So you tell me which is better, but the one thing I will say is our shrubs are reestablishing even within that bulbous bluegrass on that site. So, all right, couple fun ones, Indian Springs. This is without seeding. It came back very nice, good job. So water does a lot for you. Elevation and water do a lot. We don't have a lot of aspen long-term monitoring, unfortunately. I have like one good site that I'm going to show you, and it's fun to look at, but it's really just watching the trees grow. It's pretty great though. So this burned in 2002 or 3. That's why we're in the black there, and you just get to watch the aspen grow up as we come in. It looks fantastic as we move through time. And you can see there the aspen, we didn't have pre-treatment data. We didn't take that data in the 90s, but we're now, almost 50% cover. It's getting above herbivory levels, and it's just, it's become a very nice site there that animals can actually use and get into. Okay, that's my tour. I'm gonna get on my soapbox a little bit. So I pounded the seed mix stuff, and what I would say is there's 2 things I'd say about it. Of all the things you guys do in your treatments, the longest lasting potential legacy you leave is that seed mix. The disturbances will come and go, but that seed mix can fundamentally alter. We're not out there doing farming and tilling soil, so we're not changing soil structure that much, but the seed mix can change composition. So really think about that. Second, I'll say this is long-term monitoring. We are in a different world than we were in 2004, 2005. I've harped on crested wheatgrass and intermediate wheatgrass to some degree. We've pushed the mantra to go more native, especially at 12, 14-inch plus precip. You shouldn't necessarily be using introduced species. That message has been received. When we look at I don't have the data. I have the data, but I didn't think I'd have the time, but Maeve gave me some, so I'm taking it. But we're now in 80+% natives, even in our fire rehab on grasses. Forbs, they just aren't available to do that, but the grass world, we have shifted and are using more native species, so well done on that. The things I guess I'd pound though on the seeding side of it is, I think we play it a little cautious sometimes and seed for the sake of seeding, and there may be times where we can back off, and this data shows that we can get really good response. And being creative in that, maybe we don't need as many perennial grasses, and so that we can get that natural rebound of some of those forbs in there, that we can benefit some of those species there. I know, and again, I'm talking wildlife perspective. I know there's other objectives out there, but tailor your mixes, and I'm glad to help you do that. Tailor those to the site needs and the threats to that site to meet what your objectives are for that project and the potential of that site. Go as little as you can. Seeding is expensive, and so if we can let the natural recruit. I think we underappreciate what natural recruitment is, and we need to be better on the research side to tell you maybe where that threshold is. The other thing I didn't talk about in the mastication treatments, the data I didn't show, you guys are actually really good at selecting when you need to be seeding. The data shows that when we don't seed, we get just as good of a response. Our pre-treatment data, or our pre-treatment community, is more depleted in the seeded sites than it is in our non-seeded sites, but we get similar responses to it, meaning that seeding is working. but you guys are selecting correctly. So you're doing an awesome job. And I don't want to minimize that at all, but we can always improve. Also consider other options, transplanting versus seeding. The other thing I think we need to maybe be a little more creative in is our weedy controls. I don't know that we do the delayed entry as much as, like Nevada, that's their protocol is wait a year, spray plateau and wait a year. We do some of that, but I don't know that I see as much of that as we maybe should be doing to get good establishment of those seedings. Rejuvera is coming on as a tool for the BLM especially. Take advantage of that. But if you were here for my last talk, please don't use it with seeding. Wait until you have something established. Know that your community is going to come back with that. And then I just wanted to hit, because some of Scott's work on the Pinyon Jay and some other things. Mule deer, when we talk about treatment size and shape, the mosaics, let's make sure we're leaving corridors for big game. Makeda hit on it as well. They need that thermal cover. We don't need to do fence line to fence line. You guys are really good at that, but sometimes it's a little broad. Also, mosaics on the landscape. When we talk several states, maybe we can leave a treatment a little longer, let those come up for the Pinyon Jay, something like that. Just being creative that way to create this landscape of heterogeneity. That's really what I think we're going for. And I just put in there on the aspen, go big or go home, because otherwise the deer and elk are gonna, and cattle are gonna eat those seedlings. The herbivory pressure has been shown to reduce those. So there you go. A really cool one from back in the day on the range inventory stuff. So, okay.
Okay, questions?
There shouldn't be. There's no information in there.
Are there enough range trend sites that have been burned over to look at soil burn severity and influence on need to seed based on that burn severity?
I have no idea where that came from, but there might be. That'd be tough. The one we've recognized this for a long time too is one of the limitations with range trend is is a postage stamp within like these treatments, and so if we were a little more replicated across treatments, it would probably be better to get that kind of information off of. But we are at a large enough landscape that maybe we could tease some kind of information off of that. But yeah, I don't know. I can't answer whether we would. I'd have to look at that and see number of sites that have burned.
Am I on? Oh yeah. Hey, so spike versus harrowing, do you have enough data to like compare the two? And is there any differences? It seemed like in a lot of the harrow stuff you were losing forbs, and I just wondered if that was the same case.
That's a good point, and I should have probably, that was one of the treatments I was thinking I should have included, was some spike treatments. I haven't looked at the direct comparison there. I do think your spike treatments probably do maintain your forb component a little bit more readily. Clint's got one back there, but yeah, again, I would welcome anybody to look at these. These are open. You can peruse those. They may be hard to query on disturbance type. That's maybe one limitation to the database is we can do it in-house, but the public interface can't as well. But yeah, no, spikes at higher elevation at appropriate sites, spikes a good option as well over harrow. So, Clint?
Yeah, a couple of things real quick. Maybe not questions so much, but a couple of things I really appreciated just saying. And one of them that jumped out to me is how we underappreciate natural recruitment. I think a lot of times we just get stuck in, we want to force that site to become what we want it to become. And yeah, it's got a lot of potential to heal itself. And I mean, a lot of us fall into that. And I mean, I've had proposals recently where I was told by some groups, like, we will not fund your project unless you add this, this, and this. And I'm just like, guys, you don't understand the site. It's got a lot of potential to come back naturally, and I just don't need that. So I really appreciate those comments about that. And then I really like the picture with the native annual sunflowers. And that's one thing I've talked a lot about is cover cropping, but using our native annuals as our cover crops in our seeding, and how it's those species jump up, they're there. Those first couple years, there's a lot of benefit to it, and then they slowly decrease while a lot of those perennials come in the long term. So I really like that photo, and you talking a little bit about that.
Yeah, and I would throw in there, I mean, so I've harped on perennial grasses. I don't necessarily feel the same, or introduce perennial grasses. I don't necessarily feel the same about introduced forbs, because for that fact, I think they can serve as a cover crop, a soil building. I don't overdo it, obviously, but they fade. Our data shows that repeatedly. They come in at nominal amounts. I'm talking alfalfa, sainfoin, small burnet. They come in for a limited amount of time, help some of that nursery soil building, their legumes, nitrogen addition, and they can serve that purpose as well. We're limited, I totally agree. We're working towards finding more options for early cereal native species to use. We are fairly limited in bee plants and sunflower right now, but I do think that they are good early cereal plants to put into mixes. So, sorry, anyone else? Go ahead.
Tour, you didn't mention any pile burning, and I know a couple places where they've wanted to start seeding the piles because of soil.
Yeah, so I mean, we don't monitor a lot of those. That's part of the problem. This is because the assignment was long-term monitoring. It was, looking at those treatments that we've done more long-term. Pile burnings maybe a little more recent that we've done more of that. But absolutely, we don't have a lot of monitoring up there. Again, our program was more focused to big game winter range. We are starting to move up slope as we're appreciating more the importance of summer range, but our historic data is really in those more winter range communities. So I don't have a lot of information there, but important to consideration for sure. Oh, Buck's got one. If Tyler doesn't get mad at us going into break a little bit.
No, this is good.
I was just curious, are you establishing new sites?
Yes.
As you go along?
And thank you. That's something I definitely want to point out, especially if you're trying something that's somewhat novel. We definitely want to capture that. That's part of this adaptive management, right? And yes, we're always, when we feel like the WRI sites in particular, we will drop those after a certain amount of time if we feel like, the information we're gaining has played out, and we will add sites, and we coordinate each year with the regions to do that. But if you have a project that you feel like you would like to be monitored, please contact us at GBRC, either myself or Jason Cox, and we would definitely we'll try to get it on the rotation. So.
Okay, thanks, Kevin. Okay, we're going to move into our last break, our last 20-minute break. So there should be snacks, I think, at the back of the room for this break, and we'll get started at 2:50. Okay, we're going to go ahead and get started again. Like I said, we've got 3 left. Let's start with Brad Washa from USU, no longer works for the BLM, now with Utah State, professor. He's going to speak to us about fuel treatment effects on fire outcomes in Utah. Can you hear? You're going to have to speak up.
Hopefully I'm a little louder than Tyler. Is that okay? Because otherwise shouting, I don't think there's any other option. So this presentation was actually a joint presentation done in 2021. We were still in COVID. I'm not sure if any of you actually attended the 9th International Fire Ecology and Management Conference. Show of hands. I figured nobody. So, it did have at least international showing, but we never really talked about this within Utah. At the time, I was with the BLM. I retired 3.5 years ago from the BLM, so I'm really happy about that, considering the events of the last 100 plus days. I did this talk in conjunction with Jamela Thompson, and then Larissa Yoakum was the PI on this project. And so this is Jamela when we were doing our talk back in 2021. This, I think, was the dress that I had. And I was thinking about wearing that today, too, shorts and my wrestling shoes. But so anyways, I have since moved on, retired from BLM, and I'm now with Utah State University. And when I left federal service, I saw a lot of things as far as what I felt was wildfire misinformation. And I'm not going to take away from Don's talk later on with the park record, but did start trying to respond to a couple of agency folks. Is like, now that you're retired, why don't you start responding to these? And I thought that this had kind of died down, and then this spring all of a sudden started seeing some commentaries about what's happening as far as some of our land management practices. And this most recent one kind of ties into today's talk, looking at fuels treatment effectiveness. And I still think, a lot of misinformation is out there and being used. And in this case, it's identified that over a 15-year period, wildland fire had only a 1% to 2% chance of even encountering a thin forest or a fuels treatment. I tried finding that source. It actually looked like the link didn't work, even though this was posted in April of this year. It looked like it was from the Mail Tribune, a newspaper out of Medford, Oregon. And so I have, USU Extension has a great avenue as far as getting information out, and have used this Ask an Expert. And within this piece that we just pushed out last Friday, did talk a little bit about treatment effectiveness and how thinning of forests are not actually increasing fire danger as was presented. So I'm going to look at my presentation, back to 2021. And I kind of focused on some of our BLM fuels treatment effectiveness, and then we turned it over to USU and Jamela. So at the time, the National Fire Plan came into being basically in 2000. So we started getting influx of funding 2001. So the data here is looking at 2001 through 2021. And looking at the accomplishments that we had within BLM at the time, we had hit over 1 million acres, 1.3 million acres of treatments across the state. And those treatments are throughout the state, including both treatments in the triangle, were more wildland urban interface projects, circles were non-interface projects, but largely throughout Utah as a whole. That was accomplished with a budget of $202 million at the time. We have seen influxes and increases in budgets since then with various bill incentives and the IRA and that sort of thing. But to accomplish that 1.3 million acres, we had 2.2 million in addition to additional funding from WRI. And this doesn't show the whole breadth of it, but it does kind of show the right half of the pie chart is BLM funds, and then all those other funds that WRI were able to leverage with those base dollars. Treatment breakdown up until that point in time was 81% of our treatments were mechanical, 13% prescribed fire, and 6% other, so chemical treatment into a treatment, and you can see where fire went from being a crown-dominated running fire to a surface fire where we could get firefighters in and could also pinch it off with aerial resources. So with this, actually it was the Pine Creek fire. With this, you can see the fire moved from north to south into that fuels treatment, and they were able to use that fuels treatment effectively to stop the fire. We had some other examples in southwestern Utah in the Color Country District where the Ash Creek Fuels Project, and that had a success. That was written about in the Journal of Forestry 2004. And you can see where the Blue Springs fire burnt down into that Ash Creek Fuels treatment, and largely, resources and the change in the vegetation was able to suppress the fire, even though I think at first you can see the retardant in the photo where they didn't think that the fuels treatment itself would be effective, just because how hot and aggressive the Blue Springs fire was. So we started having these examples, but we looked at how can we cumulatively look at showing that we're having success. So we started actually with a Utah interagency database, and I wouldn't even say database, it was a spreadsheet. People would send me their data, and I would populate that. We then went from that to actually having a web-based site, FTEM, Fuels Treatment Effectiveness on Wildfires. Pacific Northwest had developed this, and it was incorporated interagency-wise nationally by both the Department of Interior and Forest Service. And we're in what today we now in the Interagency Fuels Treatment Decision Support System. We have FTEM, where it's geospatial, and you'll actually get kind of an alarm saying that there's a wildfire that appears to have burnt into a fuels treatment, and you need to go in there and validate that. We continue seeing, though, examples of fires where they have had different influences from wildfires. This is, I believe, 2017, the Ellerback fire, just 3,600 acres. During that same lightning bust just down the road was the Bunch fire that was ignited in a mastication project. They were able to get engines directly to the fire and hold that fire at 16 acres in size. And here's that lightning storm that came through the area. I don't know why it doesn't show it on here, but the Ellerbeck fire was right up in here. So just down the road was the Bunch fire, only 16 acres. I do know, some of the resources, some of the suppression resources are not too excited about fire in the mastication fields. There's more smoke production and a lot of times need to use a little more water to extinguish it, but it does keep it on the ground, on the surface, and does not get in the canopy, and we're typically able to keep the fire at a smaller size. We did run the Bunch fire if we weren't able to get resources in there and it hadn't done the treatments. That fire could have gone anywhere from 1,200 to 5,000 acres in size based on a wildfire decision support system run. And you can see that the fire itself has stayed within that purple bullhog treatment. And it was 2018, I think it said 17. The year I retired, 2021, in central Utah, just above Price, was the Bear Fire. Bear Fire was just over 12,000 acres in size, and that fire burnt into the Price Canyon fuels treatment. Price Canyon, largely a ponderosa pine-dominated community that was being encroached by white fir for the most part, was thin, piled, burned of the piles, and then understory burn. And those treatments occurred probably about 10 years. The last of those treatments occurred about 10 years prior to the Bear Fire. And we can see what the outcome was outside of those treatments, where we had a stand-destroying type effect on the more of a white fir type community. And you look at that burn severity map, and definitely in the hatched area up in here is the Price Rec area where the treatments occurred. And you look at severity levels, and other areas we were looking at 40% plus in the mixed conifer. Within the Price Rec area, 3% in the high severity. So definitely can see where these field treatments have had an impact both on the extent and severity of fire. Going down, this is kind of my tour of Utah. This is down near Moab, Pack Creek Fire, same year, 2021. That fire burned 3 homes and I think 4 outbuildings, but largely stayed within the untreated, or initially stayed within the untreated riparian area before going up on the forest. But because of those fuels treatments, they basically identified that structure loss would have been a lot greater than just 3 homes. In that year 2021, this was just some examples of encounters that occurred within the BLM, 26 total encounters. And the interesting thing was, did the treatment change fire behavior? 24 of those changed fire behavior, 14 allowed for some help in controlling that fire itself. So over time, up from 2002 to 2021, there were 2,365 treatments within Utah BLM. And over that time, 341 treatments were intersected by fires for 14.4% of all of our treatments. So a lot higher number than what that newspaper article portrayed as 1 to 2% of all treatments. And these are occurring across all of Utah. And one thing started looking at, shortly after the National Fire Plan in 2000, Utah did continue to see a number of large fire years. In 2005, 6, and 7, we were looking at 2,000 to 400,000 acres of fire on BLM lands. After 2007, there was only 1 year, 2012, where we did see actually more acres burnt than were treated by fuels treatments. And starting to question, cumulatively, are these fuel treatments on the landscape having an influence on why we're not seeing as large of fires that we were seeing in the early 2000s? So at that point, BLM Utah, Region 4 of the Forest Service, and the Forestry, Fire, and State Lands, we got together and provided some money through the WRI to USU to look at this as far as from an outside view. Our fire treatment, our wildfires and fuels treatments interacting on Utah lands. And this is where Jamel started talking, so I'm going to follow some of her notes. But she looked at 3 things in her thesis work, and she did finally complete that. The first was encounters and proportions of treatment effectiveness. The next was burn severity. And last, ecological health metrics in sage steppe ecosystems. So the focus of this will primarily be on ecological encounters. So with that, she did collect, or she was looking just at Forest Service and BLM lands, and did not look at, just because there are data sources available with those 2 agencies. Not that there weren't encounters occurring within state treatments or Park Service treatments, but that's where the data was available. So of her treatment data, these are the fuels treatments that occurred across Utah, both on Forest Service and BLM. And then for her wildfire data, she included additional data beyond the interagency data that was provided with the Utah Forest Institute and Monitoring Trends in Burn Severity database to come up with a wildfire layer within her analysis. So looking at these treatments and the extent of those on the landscapes, there are a number of areas as far as treatment occurrences. So we have a treatment footprint, but then we have treatments that many times are stacked on each other. So you might have a thinning, a piling, a burning of those piles, and then that understory burn, or a seeding and a mastication. And in some cases, Jamela found that there were 18 individual treatments on that same land base. And those 18 treatments, that was a fuel break maintenance. So every year they go out there and mow that. So, but in this case, the yellow and orange colors are like 1 or 2 treatments. When you get into the purples and darker blues, that's looking at multiple treatments on the landscape. So looking at the numbers that she came up with, there were 1,200 individual treatments, just 1 treatment on the landscape or on that footprint. And then 1,800 where there were multiple treatments. The 42% of the treatments were single treatments, with 55% being multiple treatments. The wildfire overview, she looked at 1,500 wildfires were used across, and in some cases they did repeat that burning on the landscape. Two areas actually experienced 6 fires over the time period with the total footprint of 3.3 million. And if the individual purple dots are the number of fires that occurred in a given year, the red dot or the red lines are the acres that burned for 3.3 million acres analyzed. So when we look at encounters, Barnett in 2016 identified nationally that 6.8% of treatments were intersected. Larissa and Jamela did separate out encounter rate by treatment. So you could have a treatment, and in this case, 3,208 treatments were looked at with 276 encounters, and that's a rate of 88.6%. So you could actually have a treatment where multiple fires burnt into that treatment. On the flip side, on the wildfires, we had that 1,500 wildfires were analyzed with 112 treatments intersected. And again, you could have multiple fires that burnt into treatments. So in that case, we see a slightly higher average than what was devised nationally. And just to look at an example of an encounter, the green is the fuels treatment. The pinkish color is the fire, and you can see where the fire has, this example, has burnt into several fuels treatments. And one thing identified, which makes sense, larger treatments did experience more encounters. Also, older treatments that had been on the landscape over the time period also encountered more intersections. So, and this just shows that. So if you had a large treatment, you were more likely to be burnt, but it'd be a smaller proportion of being burnt. If you had a smaller treatment, it was likely that the entire treatment would be burnt. So in summary, did see, those number of encounters, at least from USU's study at the time, looking above what nationally occurred, in the 7 to 8% range, and then further down in Jamela's study, she did look at burn severity and then health impacts and matrices. So with that, I did ask the BLM if I could get updated data. I was told I needed to request a Freedom of Information Act to get new data, so I kind of dropped it at that and didn't pursue things. But I did go into the FTM database to look at the 3 federal agencies that were reporting treatment since FTM was developed. And we can see that the individual lines here were the number of treatments that were intersected. The straight lines were based on data from the Great Basin Coordination Center as far as the number of acres that were burned. So number of treatments are on the left side of the y-axis, acres burnt. I do have a little concern. It would be great if the BLM really was showing an increase in that many treatments burned. I do think that they're actually counting, when we look at, and there is agency direction that you're only supposed to count 1 treatment footprint. So you should not count, like, again, that burning, piling, and thinning should not count for 3 treatments that are intersected. It should just be 1 location. I think all 3 of those are being counted, but I don't have the permissions to go into the system far enough to look at that. So I do think that number maybe is a little elevated. I feel a little more comfortable with the Forest Service, just the way their fact system pulls in data. They do look at a footprint versus individual treatments. And then, you look at 2004 for the Forest Service. That seems kind of high for not a very large fire season, but you look at the Yellow Lake fire that occurred at the end of the season, and there were 22 intersections on that project. So I do feel pretty comfortable about that. And if you look at, again, the effectiveness of those treatments, and just looking at last year's data, again, with that BLM number probably being a little elevated. Am I out of time already? Wow. Okay. Oh, we started at 22. I was thinking, okay. So with that, I'll wrap things up, but 91% of the treatments did have a change in fire behavior, and 93% did have help in controlling the fire. So a lot of cooperators, again, Forest Service, BLM, Forestry, Fire, and State Lands put money. Also, the Quinney Foundation funded parts of Jamela's study. And here is my information, my contact information at the bottom of this. And just one last plug. I was going to leave this up there when I was asking questions. The Utah Prescribed Fire Council, we kind of planned our spring trip tomorrow in conjunction with this meeting. So I think I have 2 lunches because I had 2 people cancel on me today. So I have 2 extra lunches and plenty of snacks from Costco. So I'll be around if there's further questions.
Okay, thanks, Brad. Okay, next up we've got Jody Gill, who's going to speak to us about the use of drones and UAV technology. Jody, welcome.
Thank you, Tyler. I appreciate the opportunity to be here. By way of introduction, I'm a kid from Beaver, Utah. That's where I grew up. Part of my training came from Utah State University. Bachelor's degree and master's degree in plant science, agronomy specifically. And I have 2 assignments. I serve as the agriculture agent for Sevier County and also have an ag-related economic development and natural resource assignment for the southern part of the state. So pleased to be with you. If anybody should get credit or blame for inviting an agronomist to arrange science meeting, you can maybe bring that up with Tom Tippett or Tyler. If you have some concerns about how an agronomist got invited here, you can deal with them. But I am glad to be here. I will say WRI is an extraordinary, amazing program. I applaud each of you for your work with WRI. And I will say I'm rather jealous of you. If WRI would have come along about the time that I was completing my training at USU, I would have been sorely tempted to be part of you. I remember Leonard Blackham and Mike Styler and others back in the day in 2007, I believe, when WRI, the idea was conceived around the importance of partnerships and collaboration, and WRI was born, and look at where you are now. It's amazing to think about 2,861 projects, 2.28 million acres treated. You do the math, Utah has 54 million acres. So that's over 4.2% of the entire state surface area has been treated with WRI. And when I say treated, restored, and conserved. So that's amazing. And over $418 million invested. I use that word deliberately. I don't look at that as a cost or as an expense. It's been an investment in the ecosystems and the productive nature and management of lands across the state. So my hat's off to you. I'm going to ask a couple of questions, ask for raised hands. So how many of you have used a drone for recreation? Raise your hands. So maybe 10%. So how many of you have used a drone for a vegetation treatment effort? Half a dozen maybe. So how many of you are considering using a drone in vegetation treatment work professionally? So a few more, maybe 30, 40%. How many of you are considering using a drone to apply herbicides specifically for vegetation treatments with the drone? So another pretty good amount, so thank you. Herbicides can be applied by ATV, truck, by hand, and tractor applicators, but I've been asked to address drones specifically. I will confess that I'm not as much of a drone expert as I might appear to be, but I've learned a lot about drones in the past. Drones have been kind of more of a fad. They've been more more of a curiosity for a number of years. I'm going to talk a little bit about history and a few things, but I would like to acknowledge these individuals at universities and then those here locally in the private sector for a lot of the information that's here. And I'm not talking about drones that are male honeybees, and I am not talking about drones that are uncrewed military aircraft. The Merriam-Webster definition of a drone is a small, remotely operated rotorcraft, usually mounted with a camera, and it says relatively small. Well, small is relative given where we are. So here's what I'll speak to. I'm going to, in typical fashion, by the way, Brad, welcome to Extension. We tend to go a little bit long sometimes, so I'm going to rush through this, but I'm going to talk a little bit about history, types of drones, application methods, practical use, and then the use of pesticides or herbicides in application. So recreational drones are small, mostly used for fame on Facebook and YouTube. Some use it to spy on their neighbors, which we would not necessarily recommend. Small drones with their infrared cameras have developed a lot of use for search and rescue, for mapping. Agriculture drones have come into a whole new a sphere of development. They're much larger. Their small drones, ag drones, are still used for crop surveillance and for mapping. The bigger drones are used to apply liquids as well as solids. So liquids, I'm speaking specifically of pesticides, herbicides, insecticides, fungicides, etc., or liquid fertilizer applications such as nitrogen, phosphorus, and potassium, or micronutrients applied as a foliar fertilizer. And then ag drones are being used, and I put this in for those of you in the fire area, as incendiary capsules for starting controlled burns, also used for seeding, and also for fertilizer on some of your projects. Some of the features of large agriculture drones. They are coming equipped with RTK, real-time semantics, wireless GPS capabilities. They sense the terrain. They can handle undulating land or hilly areas. They're equipped with radar for collision avoidance and LiDAR specifically. And more of the LiDAR features are increasingly being developed. Most drones have 2 or more rotors. They have 2 or more arms, sometimes 2 or even more. The modern ag drones are equipped with, can hold approximately 15 gallons of liquid, which is significant. The first types of drones did not have that capability. They can handle easily about 200 pounds of payload that they can lift vertically. The rates these drones are using to treat our agriculture crops and also vegetation treatments on rangelands can be as low as about 1.5 gallons per acre. They fly about 12 feet above the canopy, again using GPS coordinates and terrain and contours so they don't crash into the vegetation. They can travel up to about 30 miles an hour, and they can treat upwards of 40 acres per hour. So the technology has finally gotten to a point where it's practical and useful. They disperse these materials, liquids specifically, by spinning discs. They're usually referred to as atomizers. Also use standard hydraulic nozzles for liquids, or can use a drop hose if you're choosing to apply a liquid inside a surface of a pond to control aquatic weeds like Eurasian milfoil that's affecting a lot of our areas. I do want to mention, and I'll repeat this in a minute, there's significant advantage of drones from the prop wash itself. The prop wash meaning the air movement coming down into the canopy that further disperses and spreads whatever you're trying to apply, which is a huge advantage. Costs, if you're outfitted, can be in the $45,000 range. If you're applying like 1.5 gallons material per acre, your application rate or costs range from $12 to $25. So the application cost is competitive with traditional land herbicide application equipment. If you're spraying small acreages, there may be some additional costs. If you're treating very thick foliage, we recommend going to 5 gallons per acre instead of 1.5 gallons to be able to take advantage of the prop wash to push that material down into the canopy. If you've got tall brush, you know, in my world, if you've got tall corn and you're trying to control spotted alfalfa aphids and the corn's 7 feet tall, it's hard to get the pesticides down into the canopy. It's the same with scrub oak and maple, etc. We recommend going to those higher gallonage, taking advantage of the prop wash. As already mentioned, traditionally we've used fixed-winged or helicopters to apply herbicides, insecticides in agriculture. There's always an onboard pilot. So as we have advanced in drone technology, since at least 2009, when the first multi-rotor drones really came on the scene, they have many practical and economical benefits. From Fortune Business Insights, this number is getting just a little bit dated, but in 2023 they dated the current or semi-current industry as about a $5 billion industry in the world, and they're estimating in the next few years to get up as high as approaching 19 billion. A little more history. Japan started the industry in 1990. China built their first multi-rotor drone in 2009. They really didn't get going on their industry in 2015, but then notice what they did. In 2016, just within a year, they had 200 companies, they had 169 different models, and they sold over 10,000 units just within a year. In Japan, by 2016, they had 2,800 drones. They treated 30% of the rice crop in Japan with drones. See what happened in 2020 and 2021. By 2020, China treated over 64 million acres, mostly rice, with drones. 2021, they had over 120,000 drones in operation, over 200,000 pilots. They treated north of 175 million acres of crop ground. By 2023, South Korea was treating 30% of all of their acreage with agriculture spray drones. The U.S., we really have not gotten into the drone business and adopting that technology until as recent as 2020. So we're kind of Johnny-come-lately. A little more quick history. Japan really started in 1990, and it was a small unmanned helicopter with a single rotor, gas-powered. It would fly about an hour. It could only carry 4 gallons of material, and it was 4 minutes to empty, so it wasn't particularly practical. None of those units were sold in the United States, and it took a team of 2 to 3 people to be able to operate them. Currently, here's a list of various manufacturers. American technology, the software is very lacking, but it's secure. If you're following the drone industry at all, you know the concern, the national security issues associated with any products, especially drones that are coming from China. But frankly, they have the very best software for doing what we do. Some of the advantages, as previously mentioned, the drones can handle undulating surface. Unlike a truck or a tractor, they don't get stuck in the mud when there's water in the field or water in the pasture. You don't smash your standing crops. As many of our aerial applicators have shifted to the more lucrative fire rehab industry, spreading seed and whatnot, we don't have access to aerial applicators for our agronomic crops locally like we used to. Drones are filling that niche. They're efficient. They can handle small, irregular shaped fields, much less fuel required. There's very little exposure to the pesticide applicator. They're not sitting in a cockpit or in a tractor seat while spraying it. There's kind of and they're very precise. Using a two-step approach, They'll use a multi-spectral camera to map a field, and then they'll upload those polygons and then come in and apply them. My time is getting really short, so approximate costs in 2019 were over $120,000 for a drone, and we're much lower than that now. One of the disadvantages are current drones, because of the development in technology, they become rapidly outdated and they rapidly depreciate. They don't handle wind particularly well, and they do require licensing. Very briefly here, there's 2 licenses specifically. Part 107 certificate to be able to fly a drone in the first place, and then a Part 137D to be able to apply pesticides with the drone. And the paperwork has gotten much easier recently. One restriction, unlike other countries, you can't use 2 or 3 drones in a swarm to spray an area. We can only use single drones. And applicator licenses are administered by the Utah Department of Agriculture and Food in Utah. Various types of pests that we can manage. The newer drones are really starting to incorporate LiDAR, radar, where they can actually identify an individual plant that you want to get rid of. And our large agriculture sprayers now, which are north of $500,000, can see that individual invasive weedy plant and spray it. Our drones are moving that way as well. Surveillance use using infrared photography for plant stress in an agronomic field. You can use them to document research. You can use drones and their infrared camera to find elk on the left, wolves on the right, and people that are lost. We're doing a lot of show and tell and helping our farmers and ranchers learn more about the technology. Basically, they come on a trailer where you do the staging and the mixing of the materials. They have a large onboard generator to recharge batteries with. The batteries will last maybe 10 minutes or so, but they continually change those out to spray a field. They have pre-mixing tanks for liquids, and they can also have hoppers for seeds. This is the handheld unit, and if you look in the center right here, that's a grid that drone will fly on a precise GPS determined flight path. So you can set them up to be very accurate, and plus all of the information that's there. This is a map of an actual field. This shows the flight pattern, and the diagonal lines are where the drone ran out of liquid spray, flew back to the staging area, was refilled, and then it flew back to the same spot, so the entire field was covered. So there's no skips or misses. They're good for irregular shaped fields as well, which would be common in a range situation. Here's agronomic crop production. We've got a few videos here to show you. So from the staging area, it goes out to the beginning point. Once it gets its bearings, and notice the prop wash down below the drone, where that air, it's not spraying yet, but it's mixing that air in the canopy. It'll make a little more adjustment here in a moment. And then it'll start right there, begin its pumps to spray the liquid, and it will fly the predetermined pattern on that alfalfa field. Or if it was in a range environment, the same thing. This one shows a little bit of the easier shows the herbicide being applied and how it falls on the crop. He's not refilling with diesel or gasoline. He's just using that type of a handle to refill the tank with herbicide that's been premixed. This shows swapping out a battery, which happens very fast. They'll usually have 3 batteries on the trailer. And it only takes a few seconds to trade those out. Once it's refilled and the battery swapped out, then it's good to go back and resume the same place in the field that it left off. It has a low quantity liquid sensor on the drone, and it does it all automatically. When it runs out of herbicide, the sensor tells it to return to the staging area, and away it goes. Range applications, the process is all still the same, just as if you're applying and treating a field. Now, you'll probably, many of you know that drones aren't supposed to be flown in the dark. And I'm trying to decide if this was in the dark or not. The sun is obviously set. It's dusk, but this is treating a sagebrush patch. When you're all done, you load it up, fold it up, put it back on the trailer, and you're finished up. About 40 acres in an hour. My last slide, I would like to encourage all of you that are involved in planning WRI projects, and those of you who are funding these same projects. I believe that you can increase the life expectancy of the projects that you're putting on by including new and existing technologies such as additional mechanical technologies. You know more about those technologies than I do, but I think chemical is often overlooked. By coming in and doing pre-treatments before any vegetation is done, particularly with trees like Gamble's oak that has a massive underground root system, and when you come in and rail it or brush hog it off, bull hog it off, it just comes right back. But by coming in and doing pre-treatments with a host of woody herbicide materials, kill it first and then disturb it, I think it can greatly increase the life expectancy of your projects. Even with sagebrush and rabbitbrush, sagebrush has many other benefits for sage grouse, and I realize we don't want to kill it all. We need to renew the sagebrush many times, but by judicious use and incorporating herbicide applications into your projects, I think that we can easily double the length. I heard mentioned earlier some of our products are 10, 15, maybe 20-year life expectancy. I think that could easily be doubled. And then there's a variety of other post-treatments efforts where you have some misses that could be incorporated. So this is a summation of my presentation. If you have any additional questions, I probably don't have time now, but I'd be glad to field those.
I think we've got time for one or two. Anybody's got a question? Okay, Buck. How are you tying in with Aggie Air?
With Aggie Air, tell me what you're meaning specifically by Aggie Air.
Are you using any Aggie Air services for this, or have you talked to Aggie Air about coming up with this capacity?
No, not specifically. We leave that to the private industry to really take advantage of the technology that is in the marketplace to use that. If you're speaking of local businesses or businesses here in the state.
This is Aggie Air's out of Utah State. They're really trying to build a drone program. They build their own custom drones and things, and I was just wondering if you guys were coordinating with them at all.
We should be. I've recently met some of the new people involved in that, but I personally have not developed a relationship with that part of USU.
Thank you.
Jody, have you got a list of contractors that operate in the state that maybe we can disseminate to see if, I know there's a lot of folks interested in this, I think they just don't know where to go next.
Yeah, I don't have a specific list. It used to be where we had one in the state. 2 years ago, I had one in Sevier County. Now I've got 3 in Sevier County, maybe 4. And so just in the last 2 or 3 years, there's been many individuals that have gotten into the business because it's finally practical. So short answer, no. But yes, we can help you get in contact with many of those that you could contract with to do WRI projects. We can put a list together.
Perfect. Okay, thanks, Jody. Okay, last up, we have asked one of our local papers editors. So Don Rogers is the editor of the Park Record in Park City, and we've asked him to come and help us figure out how to better interact with some of our local papers and get our message out. So welcome, Don.
All right, thank you. I almost missed coming up here because I was looking at flamethrowers, and the brush is awesome. Anyway, so I'm the editor and publisher of the Park Record up in Park City, and we put out 2 print editions a week, and we're online all the time. Way back when I was a wildland firefighter through most of my 20s in Santa Barbara, and I literally came out of the woods to my first paper. I learned on the job, including how to type. So since then, I've been working at papers across the country, mostly small papers, and for the last 25 years, I've worked at Ski Town Papers. I bring that up because my colleagues all came to journalism much differently than I did. Basically, they're people who grew up in cities and suburbs, went to college and learned how to cover cities and suburbs, and even in the mountain towns, that's what they cover predominantly. And so my point is, we tend not to be very knowledgeable about what you guys do. And so on top of that, the work of journalism is basically lay people who are covering experts, you guys, for other lay people. So we know next to nothing about what you do or our sources do, and pretty much the definition of our jobs is we know just about nothing about almost everything. So that's what you guys are working with when you encounter us. I would say in our defense, reporters tend to be fairly bright people. They tend to be quick studies. They're used to learning quickly, and they'll pick up quite a bit, but they're not going to get the nuances of what you do. They're not going to get the ins and outs. And so as a result of that, there's going to be I guess we're going to miss things in translation. Our focus is, unsurprisingly, we're trying to explain what you guys do for lay people, so ordinary audience, and we're trying to cover your story in ways that would interest them, predominantly by showing them what the outcomes mean to them in their language and in their lives. And so that comes later. And so one more complication is the nature of our business these days has been difficult, particularly with as the advent of social media and the large aggregators have basically taken the advertising, I guess you could say, the business that we used to get and then would plow back into the journalism doesn't happen like that at that rate anymore. And so you see, as a result of business propositions, I guess, that puts pressure on staffs. That's why you see fewer journalists out there. And so that adds to what I'd say is time pressure on a reporter coming to get your story. They will also have several other stories, largely thanks to people like me that have assigned them about 5 stories during the week in addition to your story. So basically what you got is smart, smart people, very time pressed. Oh, look at that. And basically doing their best. With controversial issues, say prescribed burn that's coming up, understand that the journalists are going to talk to your critics. and they're going to talk to people who maybe have different points of view, and they're not going to necessarily know who has the most knowledge when it comes to the story that they're putting out. So that's another obstacle. The nature of journalism also, like all stories, revolves often around conflict. Just like the fiction that we read, the nonfiction that we read, the stories that we read, there are elements of what we like to think about things in tension with each other. And those are elements of often a good story, and that can run up against messages that you want to get across, particularly with the more controversial types of issues. And finally, we'll get it wrong. That, unfortunately, is inevitable when you put all those pressures together. There's going to be, and I'm sure you have had plenty of examples of that, where it just doesn't come out right. So, is this my button? Uh-oh. There we go. I'm feeling slide envy, by the way, after Jody's presentation. That was that was terrific. So what to do with us? I think be patient and persistent. I would argue that our work is really, local journalism is really less about a single story and more about stories going through time. And so if we get something wrong or we get a large thing wrong in one report, the opportunity is there because we want to have it right. You want to have it right. So let us know so we can get that right, and we can have that basically in the public record so that over time the collective story has its best chance of being accurate. And so a community has the best knowledge and in theory at least can, to the point that it makes decisions about things that maybe you do, will have the best information to go forward with that. I would say the good news with our bad business is that you have a lot more access, particularly to the little community papers and radio stations and online-only entities, to get your message across. And so we're way more open than once upon a time, probably, to press releases, photos, briefs, op-eds that you can contribute. I think you saw some of these up on the screen when Brad was speaking. As much as you have the energy and time yourselves, if you're trying to educate the community through the press, and the press is a great way to do that, I'd recommend that. My sad joke with that I tell sometimes is, I think it's Tyler, we were talking about this, how with, I like to collect your press releases and your op-eds and your briefs and run the news that that you want to get out, the news you want to share, the good news you want to share. And then I save the reporters for the stuff you don't want to talk about. So that's my dad joke. There you go. I would say, don't be shy about story pitches with your local paper. If you have messages you want to get out and information and you think you have stories for us, even if we don't take them all, love to get them. And I think over time, again, that will pay dividends in terms of having a relationship with the local paper. Reporters get used to covering stories that you have. A lot of what you do is visual in terms of the papers and the television stations and such. So I encourage that. In interviews, remember who you're dealing with, which is a fairly smart but time-pressed layperson who's trying to report for other lay people and is not familiar with what you do. Even if they've talked to you a number of times, we're still not going to really understand what you do like you do. And so if there's something controversial about what they're talking to you about, they're likely going to ask you about that. So I would recommend that you anticipate what those questions might be, and then think about what answers you might have. And then in all cases, the more you can talk in plain everyday language that reflects what you do, how it affects us in terms of quote unquote regular people, that is going to resonate with that audience. I will say too that we're not going to let you read stories ahead of time. I'd be very surprised. The 2 times I've done it in almost 40 years, I regretted it because it turned into something besides fact-checking. But in the interest of fact-checking, if I talk to you and you give me information, you can ask me to relate back what I think I got from you. So we can do some fact-checking at that level and make sure that that the reporter understood what you were trying to get across, particularly your facts. I would say if you're, and from me being in these situations where I've been interviewed under pressure and let's say adversarial type of opportunity, I would say a phrase that works for me is practice the pause. So you get asked a question, maybe it's an intense question, maybe it's one that you want to react to. If you can just take that deep breath, think about what's really going on, what they're really saying, try not to be angry at the individual because you're actually talking to their audience more than you're talking to them, even though they're in control of the story. And if you can do that, I think you can get what you're trying to say and what's right and true across much better than if you get reactive. Reactive goes for great quotes, but it lots of fire and not a lot of light, basically, I guess is that phrase. So and we're after light ultimately. At least my papers are. Again, the more you can anticipate and understand what your critics are saying, and then have a good, simple answer, the better off that's going to be. And then generally speaking, in fire, my crew superintendent liked to use the term KISS, as in keep it simple, and then use that last word depending on what your audience is. That last word with a hotshot crew is different than what I used with giving a talk to second graders. Keep it simple, silly is what I told the second graders. That works for us in writing. It works for you in explaining things to us. And I just think it's good advice. You can't start too early establishing contact with us. If you have a project coming up, particularly a controversial project like a prescribed burn, that sort of thing, having coffee with the editor, a meal, a beater, a meeting, if you can establish and start that kind of ongoing relationship, then when you have these projects come up, because we know each other, we're going to be much more likely to get involved just on a human-to-human type of level. And I realize it's hard. It can be hard to do because if the reporters are busy, and an editor has a number of busy reporters, the editor's also going to be is going to be pretty busy as well. So that's another one to be patient and persistent. But I love to go out to have coffee or meet with you at your office or have lunch or beer, as the case may be, and then we just have a much better understanding of each other, and we can work together. understand you can't control the message that the media entity is going to put out. And I can understand frustrations with that from time to time. I've felt that. But you can have a positive influence over time by staying patient, staying engaged with us, letting us know when we've gotten something wrong. I mean, I want to know. I mean, I may not like hearing it, but I need to know, and to fix it, and then not carry on putting the wrong thing in the paper or online over and over again without knowing. There's tons of details in every edition, and I know as much as I want them all to be 100% right, the odds are not great that they really are. So if we got it wrong, I want to know about it, and then we can work with that. Let's see. So reporters, as much as I've laid out the pressures, and you have your pressures too, is they want to do a good job. They want to serve their communities. It's hard work, and it takes on elements of a holy quest in some ways, because it's most definitely not the pay side of it. Particularly small town journalists tend not to be the highest paid in town by any means. And you can be way ahead just by practicing the pause, being patient, speaking plainly for lay people, anticipating the harder questions, staying engaged with the journalists well beyond one story, play for more stories, and you'll have the best chances of getting good, accurate reporting about what you're working on over time. So, I'm done.
Okay,
Ready for
questions. Questions for Dawn.
Are our stories more interesting than we think they are?
Yes, especially Riley's story, where the massacre near Preston, Idaho occurred, and they're in essence remaking the land back to how it was. Like, there's so many elements of story for what I'm interested in that. I don't know if that's an extreme example of a great story, but yeah, the material that I watched and the drone slides that I was jealous of, I think there's stories in all of that. You know, what happens after fire? You know, we have a lot of sort of society assumptions about that, but you guys are like taking real data and can say, yeah, this is what we're finding. And I think that's immensely valuable.
Okay, any other questions for Dawn? I mean, I'll just say this, you know, we talk a lot about partnerships and relationships, and that a lot of our jobs are centered around that. I think we need to include our local journalists and our local newspaper editors in that same thing. So thank you, Dawn. I appreciate you coming and speaking with us today.
That's fun. Awesome. Thank you.
That's it. No, just kidding. So the last 10 minutes we always set aside at the end of this meeting for any kind of additional questions anybody might have for either us in admin or any of the speakers that are still here. Any final thoughts? I will say I've been asked a few times, so we are looking to have our funded project list out by June 12th. That's my goal date. We're a little behind this year. We're going to blame the feds. It's because of the feds. But we're doing our best. We've still got a few more funding partners to negotiate with, but we're hoping for June 12th we'll have a list out to everybody. Okay, anybody have anything else they want to add before we take off, or any questions?
Just remind everybody of your upcoming WRI tours. please take advantage of those, share those out to your other partners, and look forward to being out on the ground with everybody.
Yeah, all 5 of those are now scheduled. They're all on the events page, so join us for a tour. And I think most of them are in June, with one of them, I think, in July 1st. So, okay, anything else? All right, let's give the speakers and you all one more round of applause, and we'll see you guys in 2 years.